and work in that particular area. And I can't thank enough Dr. Sinha for being with us today. Thank you. And Dr. Chandan Ghosh, would you like to add something now that Sinha Sahib is here? Please.
We have really, in fact, with SASE lab, we have also lots of connections, especially through Dr. Snamani. Snamani is the magnet here to connect me with Dr. Sinha. In fact, so that way, whatever work they have been doing, and we had some joint training program also, especially in Shimla. Then when SASE team also came way back in 2014. And moreover, the kind of responsibility given to DGRE now due to this disaster, which Dr. Snamani has told me, in fact, over telephone, and which is itself that seriousness that we have taken right now. Even in Uttarakhand also, same thing happened. But this time, we are just half an hour back, the NPPC, one of the executive director came to my office here itself. Just I was busy with this meeting that they look forward to have conduct an auditing of the current one, as well as 2 more construction that they are doing, including even coal dam, which was their first project in Himachal Pradesh, and one in Ramam in Sikkim and West Bengal, and then this Ramam project, and this that is there in a barrage, but they want to do auditing, like keeping Tapovan incident in mind, that what kind of preparedness that they have to do, but because right now the search and rescue is still going on, debris is still there. So what kind of auditing or what kind of early warning? Today, in fact, we have two young dynamic professor from IIT Mandi who has developed indigenously, which is rare in our IIT. We started now that developing early warning system and keeping in track with AI, ML, and everything together there. One is civil engineer, another computer science. So they together will be speaking just after this also, after Dr. Sinha's presentation. So we want to see that how as an industry, like a leader, or rather industry umbrella that city, that which as Rubab, you have visited 30 labs. Huh? I have visited only 1 lab after Leh cloudburst that in 2010 Bihar Defense Institute for High Altitude Research in Leh. But Metcalf, of course, I passed by many times, but I plan to meet sir whenever he is free in Delhi. So we'll have more discussion on that. Moreover, that now that NPPC wants their things to be surveyed. In fact, they have written a letter to our executive director also that how it can be done. So definitely, we will work as a team to help them immediately taking this result, this event that in mind, that they want to have some expert guidance on similar event if happens, then what they are going to do immediately, keeping Tapovan event in mind in the rest of their project. So that now things are going on. We'll share with that in the after this discussion. So in that way, welcome sir, gracing this occasion, and it is an honor for us and for NIDM also. NIDM and FICCI, we have become now almost 7-8 program we have done, and making it online, OTP, online training program is something, whatever name we give, but the kind of connections, then the kind of rather I would say is a positive aspect of COVID that we have brought to this level, that we get such a illuminance, and our scientists, our thinkers into the platform with a beautiful platform created by FICCI, which is BIKE, P-I-K-E. It is not motorbike, it is a bike, that wonderful name that they have given, which is open to all the participants that who are doing across the country. So in fact, having we have one young assistant professor from IIT Jammu, where I was there till December. He will be talking on ice. In fact, he is also very intensely connected with Sase and Dr. Snamani and entire team in his research work that he did in IIT Kanpur. So he will be giving, sharing that how to, whatever things that he can do in this project as well as in this event also. And we have, of course, in this session, we have one more presentation, of course, who is a GLOF specialist from CWC, Dr. N.N. Rai from CW, Central Water Commission, that he will be talking on what are the GLOF events that in India that we are having. And he's when I talk to several people, even in NTPC or even CWC, everybody mentioned that Dr. N.N. Rai, engineer, in fact, he's the person, nobody else can speak on this. We don't want to take. So that way, N.N. Roy will be speaking on GLOF and his experience that he's going to share. And then last but not the least is that we have got Mr. Himanshu Shekhar, who is a journalist, but he's more of learner than a journalist in a sense that we understand. So he'll be joining us in the last lecture today, especially his experience that he had, real direct experience that we had, especially in disaster like 2014 in Srinagar. So he'll be giving presentation today, sharing with us that how a journalist can speak in a forum like this among the scientists. We are so-called intellectual, but his perspective, especially while seeing the things at the field, also will be taken care of today.
Absolutely.
Thank you.
Thank you. Thank you, Dr. Ghosh, for the, setting the perspective for this second day. So I would like to formally welcome our very eminent speakers, especially Dr. Lokesh Sinha, Director DGRE, DRDO, for gracing the occasion, as you earlier mentioned. Also, we have almost over 160 delegates now who've connected with us. And this number is anyways, as you can see on the right side of the screen, is going up. So we are expecting almost 150, 300 delegates from across the country, especially from the northern India and the northeastern part of India, to join us, and as they strongly believe that the combination of speakers what we have, the long, the very elite list of speakers, their knowledge would really benefit them, not only the industries, but the civil societies, the communities, and even the stakeholders from the government side. So this is a unique platform where FICCI and NIDM has come together under a partnership to organize online training programs. So this is one of the important online training programs. The theme was decided based on what happened recently in Joshimath. So I think we've swung into action immediately. We reached out. In fact, both NIDM and FICCI reached out to each other that we should do something, some sort of capacity development work, some sort of knowledge sharing work together to disseminate more clearer information on this subject and declutter and demystify, some sort of information which sort of creates some sort of confusion in the minds of the people. So decluttering and demystification is also one of our agendas of organizing these online training programs. Dr. Sinha, you'll be happy that in the past less than a year, we've organized over 10 national level webinars, 6 online training programs, and dedicated e-conclaves on earthquake resilience, cyclone resilience, flood resilience, and now very soon we will be talking on industrial safety from an international perspective. So all of this, in a way, COVID has been a blessing for a lot of people. Partners who could not work together earlier because of paucity of time or being stuck or involved in other projects, they got a lot of time, and I think we leveraged that when it came to NIDM, Ministry of Home Affairs, and thanks to the leadership of Major General M.K. Bindal, EB, NIDM, and Lieutenant General Dr. J.R. Bhardwaj, who's the former DGFMS from Indian Defense, and then the founding member of National Disaster Management Authority, who is now the chairman of FICCI CIDM board, the Chemical and Industrial Disaster Management Board. Their leadership, from Fiki's side, his leadership, and General Bindals from NIDM, we see ourselves in a position where in all our OTP programs, we've had over 300, 400 sometimes participants from not only India, but from neighboring countries, Middle East, Nepal, Bangladesh, Sri Lanka, even from Thailand. So we've reached out and we've created a platform which I hope will help build better capacities and have have better impact from a knowledge perspective also amongst the people from the industry and all other important stakeholders. So without taking any longer, I would like to request Dr. Lokesh Kumar Sinha ji, Scientist G, Director from DGRE, a lab which was formerly known as the Snow and Avalanche Study Establishment, SASE. Before I invite Dr. Sinha, I would like to introduce, although he needs no introduction, but I would briefly like to say a few lines on his background. Dr. Lokesh Kumar Sinha, Scientist G, is a director at DGRE. He has obtained MSc Geology in '84 and PhD in 1988 with specialization in structural geology from BHU, Banaras Hindu University, Varanasi. Dr. Sinha joined DRDO, the Defense Research and Development Organization, on 27th July 1989 as Scientist B in DTRL Delhi. I've had the fortune of being to that lab as well. He has more than 20 publications in peer-reviewed journal and conferences of international repute. He has, to his credit, 2 patents also on terrain evaluation and projectile-based tool for evaluation of terrain condition remotely. Very, very relevant in today's discussion. He has authored chapters in books on landslide hazard zonation, mapping, and technical reports on area analysis studies published by military intelligence. He has been awarded several awards, including the Lab Level Technology Group Award for Trafficability Map Program in 2003, National Science Day Commendation for Terrain Understanding, a Key to Disaster Management 2004, 2 Lab Level Technology Group Awards. Recently, he was awarded for his outstanding contribution in various research activities of the lab in 2017. Over 30 years of experience in terrain studies with research interests including structural geology, terrain diagnosis, disaster mitigation and management, optical and thermal image analysis, infiltration modeling, and groundwater prospecting. I think with this immense experience, I'm privileged personally, and I'm sure a lot of my participants would also agree, and that we are really privileged to have you on our platform to discuss your experience, your knowledge on this very subject. Over to you, Dr. Sinha. Yes, now you are unmuted, yes.
But I'm not seeing that share link so that I can put my presentation on.
Absolutely. Give me one moment. Gaurav, if you could please activate the sharing links for Dr. Sinha, please.
In the meantime, I'll tell you this DGRE is recently formed somewhere in November. Before that, there were 2 labs, Snow and Avalanche Study Establishment, and 1 lab, DTRL, where I was director.
Yes. Oh.
So these 2 labs merged together and we formed DGRE. And now, after this, I am heading DGRE, and the team is very good. I mean, both the teams have the experience in disasters, its mitigation and management. So now a bigger team I have to handle with to give the solutions to the defense forces in particular and general public in general.
Oh, absolutely. So in a way, you're now director of 2 labs, honestly, at one time, which is again a rare, I think, thing, as far as DRDO is concerned. So congratulations on that, sir. I'm sure both the labs will really flourish. The scientific, expertise will definitely flourish under your leadership. Thank you. Gaurav, have we shared the rights with sir?
Yeah, it is open now. So I'm sharing the file.
So you can share your screen, sir.
Yeah.
Yes, he's sir is doing that. Yes. Thank you, Gaurav.
Hello.
Hello. Yeah.
Yes, we can see your screen. Yes, absolutely, sir. Clearly, yes, we can.
So I I'll tell you something about this Chamoli disaster, what has happened, and how to go forward right now. I mean, I'll show you in the presentation. So this, if you see, this is in general is the Alaknanda Basin, Uttarakhand, which is the main river which meets uh, one of the river to make Ganges near Devprayag. So we are concentrating in Alaknanda Basin, and here you can see lot many glacial lake, the hydropower dam projects which are running, and the one which is under construction. So in a nutshell, this is the total area on which we are concentrating right now. As far as this disaster is concerned, which has happened on 7th of February, you see somewhere here the Tapovan is where the site which was most affected along with the Rani village. So if you move from the top, this is the area from where the glacier broke and it came down running through this channel which is called Rishi Ganga. This is the Rongti Nala which meets Rishi Ganga at this point, and then it moved further to meet the Dholi Ganga river, and both the channels meet together and move forwards at the Tapovan area. So in the next slide, I'll show what has happened. On Sunday, February 7th, roughly around 10 to 10:15, this glacier broke and came down heavily on the Rongti Nala. From Rongti Nala, it moved further down roughly 6 kilometers, 6 to 8 kilometers to meet the Rishi Ganga river. At Rishi Ganga river, with so much muck which was coming along with the Rongti Nala, it was deposited on the bank of Rishi Ganga river, and it blocked the flow of Rishi Ganga. So initially it was not a GLOF. It was simply hanging glacier which came down heavily in the river Rishi Ganga, and it blocked the channel of Rishi Ganga river. And finally by 10:40, in between 10:30 to 10:40, it crashed everything en route and demolished the Tapovan dam site. I'll show you one or two photographs of that in my subsequent slides. Yeah, so this I was saying, on Sunday morning, this glacier ice break took place from this area, came down heavily on the Rongti Nala, which is not visible in this particular picture, and then started moving towards the Rishi Ganga river. It was just like a flash flood with full of muck, not only water, but all these debris and all were coming down heavily on this channel. We got this information around 11 in the morning, and immediately after this, we had a crisis management meeting in the lab, and a team was selected. The team reached Dehradun in late evening, and next day morning at 7:30, we took a chopper, and before landing at Joshimath, we took the aerial recce of that area. We are the first to identify the portion where this tragedy started. I mean, this phenomena started. So this was the location spotted by my team from aerial survey, and then the complete team landed at Joshimath and started working on its effects. Here also you can see this is the image of planet of 7th February. In the morning itself, around 10:30 or 11, maybe 12, I don't know exactly the timing of the this scene capture, but you can see this portion. This is complete snow covered, and the dust which was erupted after this mountain block glacier broke down is deposited on this hill. So complete brown color you are seeing over here on 7th image itself. Now I am showing you the area. The glacier is the broken glacier started from this point, moved along this river, this Rongti Nala, and met. This is the Rishi Ganga river. This, if you can see, whole muck which was coming along this channel was moving down also, but some of it got deposited on this channel. It is around 500 to 600 meter long and 100 to 150 meter width. This blocked the Rishiganga river over here and it formed a lake. In my subsequent slides, I'll show you all those things. Then the remaining muck moved in this direction, demolished completely the Rani village. Even the muck was so high, roughly 60 meters in height in front, it went back into the Dhauliganga river also. In my simulation, I'll show you that. And then it moved forward, and here is the Tapovan Dam, where it devastated everything en route. This on a DEM I am trying to show. Glacier broke from here, came down and moved further to demolish Rani village and finally the Tapovan village. This is the enlarged view which my team took from the chopper itself. This is the area. If you see this area, it's a triangular in shape. The upper one, the cracks were developed. We have seen the images now of the previous years. The crack was visible in the images earlier also. So this complete crack from this point, the glacier which was hanging came down along with the rock mass. I have a detailed picture of these areas which I'll show you subsequently. This was taken roughly 500 to 1 kilometer away from the area, from the chopper, but the further images was taken hardly 200 meters away from this height. The height of this place is roughly 5,600 meters and the ridge line is around 6,000 meters. So from 5,600 meters, it came down into the valley along this path. This is the Rongti Nala. It met Rongti Nala and the height over here is roughly 3,000 meters, 3,600 meters. So 2,000 meter fall of this ice mass and rock. This is the general topographical sheet I am showing. This is the area. You can see this triangular shape. This piece came out from the mountain and came down heavily in this Rongti Nala. Now, this is the close view of Tapovan Dam. You can see this Tapovan Dam was here, over here, and it is completely devastated. The muck which you are seeing in the valley portion now is roughly 10 to 12 meters, and the impression of this muck is above 30 meters on the valley side. You can see this impression, light gray color. It is the impression of the muck which was flowing through it, with a front of more than 50 to 60 meters and tail of 4 to 5 meters. This is the Dhauliganga river, which is coming from north, going towards Tapovan, and Rishiganga from the eastern side coming and meeting this Dhauliganga, and then it flows. So this Rishiganga bridge, which was here, in my next image I will show, this was completely broken. Yeah. You can see the roads across the Rishiganga river. We are coming from this side, and this bridge which was here, you can see the road up to this place and road emerging from the other side from this place. In between, the bridge which was there was completely devastated, washed out, you can say. Now what I am trying to show you, this is the Romthi Gadhera Nar, which was coming from the that side where this glacier dropped, and this is the Rishiganga river which was coming like this way. This is the junction point. This was the old Rishiganga course, and the Rongti Nala muck which was coming along with it got deposited in this area. Because of this blockade, which is roughly 60 to 70 meter high, this water which was flowing earlier, because of this artificial dam, start increasing in height. You can see these two photographs where the lake is clearly visible. These are some of the other angle photographs. This is the Rongti Nala, Rishiganga river, which is coming from this side, and the water got deposited in that area. After few days, this is the photograph taken on 12th. The channel, natural channel, emerged from this water, from this lake, and it started flowing on this 60-meter high debris. And again, it is meeting the Rongti Nala. So the natural drainage has started from the lake. And in one of the photograph, I'll show you the output or the outflow. This is the closer view. This we have taken from the Cheetah helicopter, hardly 10-15 meters above the ground. And from this lake, hardly 50 to 100 meters on this side. This is the channel, natural channel, developed by this lake, and it starts flowing and coming and meeting the Rongti Nala. This is the inflow of this lake, which is the Rishi Ganga river. You see the difference between these two. So inflow is less, outflow is more. So the danger, as you say, at present is not much. The problem what we are seeing now, this channel, natural channel, because it is on the muck deposited by the Rongti Nala, it is being eroded very fast. On the 12th, it was flowing on the surface. Now you can see this depth also on 13th. If you go on 14th, 15th, 16th, this erosion you can see in this natural channel which has been formed. This I am showing you the lake. This is the upper end of the lake where the Rishi Ganga is coming and putting its water in this lake. And this is the frontal view of the lake where the natural channel has been formed. Here I am showing you the release mass area from where the material came. The total volume is very, very huge. Few lakhs of cubic meter of mud, rock, and the ice came falling for 2 kilometers, more than 2 kilometers, and met this Rongti Nala. Yeah, this is the path of that broken ice mass which was coming down. This is the confluence point, and here is the Rongti Nala, which is originating from this snout. This snout is of Nanda Ghumti glacier, and this is the total undisturbed area over here. This came on this point and start moving downward in this direction. These all photographs were taken by us only, choppers. I wanted to show you some of the erosional features because this mass was huge, more than 50 to 60 meters in front. It eroded the slopes and this wavy structure was formed, which again proves that this ice mass, which was moving from this top, has moved in this direction. This wavy structure cannot be formed with any landslides or those kind of things unless until ice and ice block is there. This type of features you will not find. This is the closer picture which we have taken from Cheetah, roughly 100 meters away from the site. Just see, it's triangular in shape and the depth over here is more than 50 meters, 70 meters. So not only the ice sheet which was hanging on this wall came down, it came down along with the rocks, or you can say it has excavated the rock from this area. And that is why all those dust, what you are seeing, all those muck, what you are seeing, is because of this mixture of this glacier and this rock mass. Again, we have analyzed this area. This has come down, but this, what I am showing over here in red circle, is again a vulnerable site for continuous monitoring of future threat. A threat is hanging in this area. We never know when it will fall. And if it falls in near future, it will create havoc. This is the downward from the top we are seeing, and the flow is in this direction. Other view I wanted to show from the top. You can see these channels, how they are growing in size and in depth. On 11, you cannot see anything over here after the dam. I mean, no water channel and all on 11. But on 12, this water channel has started. It increased on 13th, and this is the situation on 14th. 13th, 14th, 15th, I was in the area. So these photographs I have taken from the chopper. The ice mass which we saw on the river valley as well on the river slope. This is a chunk of the ice block which is of more than 3 meter dia, and it has traveled 7 to 8 kilometers to reach this spot. And take my word, this ice mass is not in the valley, it is 300 meters up on. From long distance, it looks like a normal boulder, very, very big boulder. But once we scratched it, the top, you can see the ice is visible. Ice covered with the muck. So from a distance, you will, it appears like a rock mass. But once you go closer, this was done by the SDRF team who reached first on 13th in that area. This is the general topography of that area. All the DTM we plotted, and this is the lake position. You can see it at the valley it is 2360, and at the top it is 2500 something, 2555 to very precise. This is the slope map we have prepared for this. Actually, the determining the depth is very, very important, because the area we have calculated based on its impression on the satellite data. But depth is still unknown. Today, my team was in the field and they have taken some of the measurement for the depth also. The report may come tomorrow because that area doesn't have the net connectivity. So I got a call from the team. They, for a few seconds, they said, we have taken what was required. This I wanted to tell the audience that in front, it is 60 meters. But at the back, which I was showing from where the Rishi Ganga river was coming and feeding this lake, there the depth is less than a meter. So the shape of this valley sort of thing, what has been found for this lake, is in this shape. For all our simulation, we have put it in the volume of this, we try to calculate and put it in a regular feature, because the simulation model doesn't take this type of features on which the simulation can be done. So now here you can see it is 45 meters throughout. Otherwise it is 60 meters in front and less than a meter in back. And the total volume what we calculated that time, now we have the real data of the depth also. So again we will do the simulation. That time what we did was on 0.34 million cubic meters. This was our earlier estimate. And we did simulation for the values on both the sides, like for 0.3 million cubic meter as well as 0.6 million cubic meter. I'll show you those. This we have done, I said now, length and width is more or less known from the satellite data. Here also, now my team was saying, is saying it is not 50 meters, it is much bigger than that, and they have measured it. It may go up to 100 meters width in front. On the back side, it's less than 2. On an average, you can say the width is around 50 meters. This is a three-dimensional. We tried to put it using 60 meter, what we thought earlier in front. The exact data and the simulation will be done on the data which was collected by my team today. So we have taken lake volume as 0.3 million cubic meter or 3 lakh cubic meter, and we have seen how if it breaks, then how the discharge will come. So initially for 2-3 minutes, the discharge will be the maximum, and as we move away, I mean after 3, 4, 5, 6 minutes, the discharge reduces drastically. This we have calculated on the breach. If it is happening for 20-meter breach, 35-meter breach, and 60-meter breach also. So initial 2-3 minutes are the most crucial, and after that it subsides. This is the scenario 1 where we have taken a breach width of 20 meters, and the total volume is 3 lakh cubic meters. So if it starts from here, you can see the flow height. It is all in blue, but I have the data for different heights also. This one, I cannot enlarge it on this mode, but here all the heights are written over here. Flow height. How much will be the flow height at that particular level? It is going from 17 meter, at some places 3 meter also. to roughly 27 meters. Other one with 3 lakh cubic meter, but it is the same. Next one I'll show. Lake volume 6 lakh cubic meter and beach width with 60 meter. So here you can see the heights are more as compared to the previous simulation. This one is the velocity, which also I have plotted. What you do with the velocity once it starts from the lake and how it gradually decreases once it reaches Tapovan. These are the parameters which we have used for simulation. I will not go in detail because already 3. But the simulation I wanted to show you. Just see. It is not working over here. It starts from this point. Goes like this, and it completes its journey at Tapovan. All the water which is being released after coming near Tapovan, it subsides, and finally it moves like a normal river. In the simulation, we found that the water which is coming over here, pushing it further up against the slope in the Dholiganga river up to this point. Some other day I'll show you that simulation also. So this is our simulation results. From here it is originating. These colors are depicting the height of the flow. Red is roughly 45 meter, which is at very nominal, very small areas like this. Here. Otherwise, generally it is in between 0 to 10 meters. All the blue colors. Similarly, I calculated the velocity also. Maximum is 30 meter per second, which is depicted in the red color. Otherwise, mostly it is between 2 to 3 meters up to 8 or 9 meters per second. This is the general distance of Rani village from the lake is around 5 kilometers, and it will take 6 minutes to reach the Rani village, and the height won't be more than 10 to 11 meters. So not much effect if the lake breaks also, and we are trying to reduce its volume by making another channel. That will come in my recommendation. This we have calculated the volume. This white one is the water level. This is the lake, and this is the debris in the blue. And the volume which was coming through this was around 7 lakh cubic meter in this particular scenario. And the peak discharge would be around 2,500 cubic meter per second. This was again done on a model, what we are using for the avalanches. These are some of the videos which the NTRO has taken from drone thermal, because we are monitoring this lake. We were monitoring this lake in night also. Nothing severe happens in night, so we need some thermal sensors. Otherwise, RGB sensors were needed. I want you to see this particular image. This I have, for this presentation only, I tried to put it in this. See this red spot. These red colors which you are seeing over here are the signatures of the trees which are there on hills. All the 4 images. In this particular spot, on 13th February, no red spot you are seeing. No, nothing red. But on 14th, you can see this particular dot, which is very light in color, but it is there in this red one. Here, it gets brighter, and the brightest on 13th, 14th, 15th, and 16th. What I mean to say, the water level, which was there in the lake, covered this tree on 13th. On 14th, this is the lake. Can you see it? On 14th, the level slightly reduced, so the impression of the plant was seen by the satellite planet also. On 15th, the water level further reduced, and on 16th, it reduced quite a bit. So this proves our thinking that the water level on the ground is reducing. That too from the remote analysis, because till that time nobody was there on ground. On 13th, SDRF team went over there, but they were in the frontal area here only. They have not gone inside. Today, the Navy team is with us, with the divers, the boat, and some sounder, so that we can find the depth. So, in summary, I will say the situation is not very alarming as of now. Erosion, as you know, is gradually taking place, and the water level is coming down. ITBP personnel in our team is on ground zero and have taken measurements to start working for hazard mitigation. My recommendations will be like this. It should be continuously monitored, particularly the water level and discharge. Aerial surveillance and reconnaissance on regular basis. Precaution is imperative. The snow melt regions, and particularly in the monsoon season. Analysis using multi-temporal high-resolution satellite imagery has to be carried out for coming a month or so. I have deputed my team in batches for the complete month till 20th of March. Monitoring and mapping of supraglacial across Himalayas, particularly for the moraine dam lakes, because this tragedy can happen anywhere. And hanging mass of Nanda Ghumti and adjoining basins to be monitored. One which I showed with the red circle sort of. Those areas should be monitored. That's all from my side. Thanks. Anything if you want to ask?
Thank you so very much, Dr. Sinha, for that very detailed presentation. I don't think we would have had this opportunity to know about this incident in as much detail as you showed us, and I think uh, uh, it anyways answered and cleared a lot of doubts and questions that were in the minds of our participants yesterday. So before the session started today, I categorically mentioned that there were a series of doubts which people had while joining this OTP. Their questions, few were answered on the first day, and I think a majority have been answered with your presentation. Thank you so much for that very detailed understanding, and I must congratulate you, your leadership, your personnel who are on ground zero and who are doing the analytical and research work back at the lab in partnership and with other stakeholders like ITBP, as you mentioned. Deep gratitude, and from all of us and all 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 the countrymen for the great service which your lab and DRDO and Ministry of Defense is doing to 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 help us not only prepare better for the future but also mitigate. Hazard mitigation is your primary uh, task which you've identified, and I think that is the way forward. Internationally, right now, I think with this glacier, this GLOF incident, there are many international experts and agencies which are talking about, anyways, resilience has become a global term, and because there are a lot of investments which happen from companies, especially in the power and telecom sector, and I think that's why we are talking about resilience, because they would actually follow the report which will come out of this for their future investments in the region. And I think this is where your role and your lab's role becomes so very important and pertinent in deciding the future course of development in the region. And that's why I am trying to insist on this, that we must thank you from the bottom of our hearts for the great work you guys are doing, and many congratulations and compliment.
Thanks for calling me in this panel discussion. Thanks a
Thank
lot.
you. It
Got
was
this
a
opportunity to tell whatever we have done to the people of this country. Thank you.
brilliant. It's a privilege, sir. And I think whatever we will also write to you separately, that whatever information out of this presentation can be shared for knowledge for these participants who are attending this. That would be great. I mean, because they are all, in fact, the chat window, and I'm getting personal messages also on the chat. For they're amazed to see the facts, which obviously you won't expect those facts to be shown on the media or in that detail. There are different newspaper articles which have different takes, who reach out to different experts and they formulate an article. But coming from you, as you say, from right the source directly. I think it's a great privilege to listen to your in-depth research and work which you are doing. Thank you so much, Dr. Sinha. I would just like to quickly check if I think we lost Mr. Chandan Ghosh. I would just I would request the participants, if they have any questions, further questions which are still unanswered, please feel free to come up with those questions. Till the time Dr. Sinha is with us, I will see. We can take. Otherwise, I will. We will collate these questions. We'll send out. To Dr. Saab for his views. Meanwhile, I see a question which is coming here. There's a comment from Veluru Ramesh. Excellent deliberation and valuable information shared, including actual conditions. Highly appreciate DRDO's role and presenter Dr. Sinha. So there is one question. Can we say due to slow failure of rock mass, the glacier came down to cause heavy runoff? Question for Mohammad Salman Raza, sir.
Actually, both are mixed. It's not, it's a chicken and egg story.
Yes.
Whether the glacier initiated that rock failure or the rock failure initiated the breakage of that glacier.
Which came first?
We'll come out with this answer also. Soon we'll tell you exactly what created the other. We're working on that. That is a question which we are also asking from ourselves. How to answer this? Which initiated which one? But so finally, what came down on ground was both ice mass as well as the rock.
So I think this is the part of the investigation, which is ongoing investigation, which is going on. That's where that's what Dr. Sinha also mentioned, that his team is on the ground with other stakeholders to actually collate more information, more evidence from the site to actually ascertain what actually happened, whether it was the chicken or the egg. What came first? Yes.
And one thing sure, I'm going to send you the report once it is complete. I will share it with Picky as well as NIDM.
Wonderful, sir. Wonderful, and we'll collate that because that process we collate all the content which is presented by the eminent speakers, and we share it for their further reference. And we also have this on the YouTube. So this will always be there as a repository on YouTube. People can click and visit and see, even if they want to see your presentation, they can see it as it happened live. So, the advantage of technology, and thanks to the COVID times, we are using these these platforms more extensively, so that they can even the word of mouth also. Once I'm sure your presentation has all the elements to go viral. I must tell you, when the people really want to know more on the subject. Thank you so much again. Thank you. Namaskar, sir. Thank you.
Thank you for coming.
If there is any question, we will reach out to you again, sir. Thank you, sir.
Thank you. My mail ID is there. Anytime you can write to me.
We will reach out to you. Thank you, sir. Thank you so much.
Thank you.
Moving on now, we have the next presentation or lecture or expert comments, I should say, from Dr. Divyesh Varade. Please pardon me if I'm pronouncing it wrong. He's the Assistant Professor, Department of Civil Engineering, IIT Mumbai. Dr. Divyesh Varade, a very good afternoon and welcome to this platform of the online training program where we discuss resilience and resilient infrastructure in the hilly regions. This is a very important subject, as I've been saying all along. Avalanche, GLOF, debris flow. It doesn't. The world is now so very well connected. It may not affect someone sitting, let's say, in Delhi or Madhya Pradesh or Maharashtra or Tamil Nadu, but you will see part of our audience is very keen to know more, because see, this is what the technology has brought everyone together. So anything which happens in top up north equally concerns the citizens sitting down south in Tamil Nadu, or maybe in far from the country, maybe in US and UK. And that's what I've been praising this this intervention of going digital with all our experts, with all our content, thanks to COVID, because otherwise we would have had this into a physical training program where we would have discussed it amongst 150, 200 people. But this going live on YouTube, I think, will definitely help a lot of people to understand and declutter a lot of information around this. So, as I said, Dr. Divyesh Varade is an eminent professor from Department of Civil Engineering, IIT Mumbai. He completed his PhD in philosophy in from IIT Kanpur. Doctorate of philosophy he did from IIT Kanpur. Sorry, in Department of Civil Engineering. Specialization was geoinformatics. So his doctorate or PhD was in geoinformatics. His research and experience, he's been there at IIT Jammu as assistant professor. His research interests include remote sensing of snow, glaciers, and sea ice, applied remote sensing for Earth observation, polarimetric radar backscatter modeling, hyperspectral image analysis, pattern recognition, and feature selection, remote sensing of soil moisture. All of these subjects are so very relevant when we talk about hilly regions, mountainous regions, the entire Himalayan range. I think all of these research interests are, so very specific to this, this region, and we need experts like Dr. Varade to share his knowledge. He has a series of publications, on snow, on modeling of early winter snow, on estimation of snow depths, of potential of multispectral reflectance for assessment of snow geophysical parameters in Solang Valley, and of course in Kullu Valley, of course, improved assessment of atmospheric water vapor content on Kullu Valley in India. And all of these significant great work was done. I now request Dr. Varade to please take up from here and present his slides. Thank you. Over to you, Dr. Varade.
Thank you for the wonderful introduction, Dr. Sood. And I would like to thank you for providing with this platform to talk about such an important event. Yeah, so in this talk, I will just speak about some basics, some physical aspects of glacier breaks, and I will relate to avalanches, which are one of the major disasters in hilly area, in the hilly regions, snow-covered regions, and what are the mechanisms that occur, and that trigger avalanches, and how remote sensing actually can be utilized for monitoring of this kind of a snowpack which is vulnerable to avalanches. So to start off, I'll begin with my presentation. Let me share the slides. Yeah, I hope this is visible.
Yes, it is. Yes, it is. Yeah. Yes.
Yeah. Thank you. So anyway, I think we had a very wonderful, introduction and the causes and everything that Professor Sinha discussed, and that was very informative. So I just don't want to, go back to it. And I will just like to mention that disasters as these, they have been happening for a long time in hilly areas, and remote sensing has a very important role to play in monitoring of these areas. So I'll just skip the slide and move on to the next one. We know that some of uh, the problems that occurred here, and it in some of the news channels, it is being said that avalanches played one of the roles, and it is possible these events could be assumed or it could be triggered. For example, in this case, it happened because of a glacier break, but it could also happen because of an avalanche. So this is like Professor Sinha said, it's a chicken and egg kind of a story that each one event could trigger the other, or the other could trigger the first one. So anyway, coming to some of the fundamental things, it's like in this case, it was glacier breaking. So usually refer to the glacier breaking as calving in terms of glaciology. And a lot of, in most of the cases, it can happen because of some anomalies in the temperature gradients. So for example, I have this graph here, which shows that some kind of a variation that happened during 5th to 9th. So we can see there is a slight variation in the temperature gradients during this time. So this was taken from a weather resource such as, I think, AccuWeather. And we can see that gradients, they have a very important part to play when we will further talk about, avalanches. So a break in the glacier, that is the ice fall, it is possible that the chunk of ice that falls off from the glacier could trigger an avalanche. Or in the other way, an avalanche could also trigger a part of hanging glacier, for example, to break off. So both of these are kind of interconnected events. Now, the other part of this is that the avalanche or the glacier break, if it falls into a glacial lake, it obviously, creates the problem or issues of GLOFs, as we already know. So to start off, I think I'll try to speak about what is a glacier first. So a glacier is a permanent body of ice that consists of recrystallized snow, and because of its own weight, this kind of slips down a slope. So depending upon the slope, the rate of velocity of the glacier is kind of a dependent. So usually you have different kinds of glaciers. For example, in Antarctica or Arctica, the shape and properties of the glaciers are different. While in the alpine regions or the Himalayan regions, the type of glaciers, we call them as temperate glaciers because they have this temperate climate. So their properties, are much different than Arctic glaciers. So to sum up, the glaciers they formulate as as a consequence of continuous precipitation, which can happen in the form of snow, hail, or freezing rains. And over the time, when this snow accumulates and gets compressed because of various activity, for example, wind actions, it becomes a very hard mass that we call as glaciers. Now, there are two very important inputs in glaciers. One is the accumulation zone, and I think most of the people here already know about it. The other one is the ablation zone. I would like to show here in this picture the three different zones. For example, the accumulation, the ablation, and the place where calving mostly occurs, that is the terminus of the glaciers. So this is an example of a different kind of glacier as compared to what we just discussed in the present disaster. It was hanging glacier. But the general idea is that when we have the fresh snow, it is very loose and it has a lot of air component. And as it gets older, the percentage of air in the snowpack, it kind of decreases. And when it gets to ice, the percentage of air is almost close to zero. So in this case, you can see that historical development of glaciers from the fresh snow to very hard ice. So basically what controls glacier size and mass? So we know that it is a glacier is characterized as a river of ice that flows because of its own weight. And there are the two important terms. One is the accumulation that causes addition to an existing glacier. And then we have a process called as ablation, which is the loss of ice from the glacier because of melting. Now, when we speak about all these terms, the important part is the accumulation, which adds to the glacier ice. And this process is actually related to the development of the snowpack. And that is where we sort of discuss problems like avalanches. So anyway, to first start off, let us have some information about calving of glaciers. So usually when we talk about glacier calving, we refer to glaciers that are terminal glaciers. So they are terminating either in a sea or in a lake. But that does not mean calving cannot happen in dry glaciers. For example, in the present case, in the case of Chamoli disaster, as we saw earlier, it was a case of dry calving. So it was the case where a hanging glacier fell off, a chunk of hanging glacier fell off because of some kind of a rupture in rock activity. So the idea of the rupture is basically the development of cracks and fractures that tend to grow in the glacier. So anyway, we can understand that subsequently these cracks, they tend to widen and develop into crevasses, what we call as crevasses. And these crevasses, when they enlarge, they are vulnerable to ice falls. So that is chunks of ice called as icebergs falling off a glacier. So To speak about crevasses, we speak about analyzing what is the size of the crevasse. So, for example, if we know that a crevasse is filled with water, then we know that it has more pressure being exerted to it. And in this case, if it's a hanging glacier or a glacier downslope, then a water-filled crevasse has more vulnerability to glacier break, or as we say it, the falling of the iceberg. So it's one of the important aspects of remote sensing, which is still very underexplored, is analyzing these crevasses using remote sensing data. And particularly in this case, radar remote sensing plays a very important role. So these crevasses, as we can see, they usually happen down slopes. So, but the important factor is the crevasses, along with this movement of the glacier, they can also move. So because we know that the snowpack, it is one of the most important things that adds to the glacier, as well as adds or provides information regarding avalanche vulnerability. So first we must discuss what is snow stratigraphy. So as we know that, the snowpack, it formulates in the form of different layers, and each of the layers, is accumulated in a snow spell. So because of multiple actions, the properties of each of these layers is different. So each layer would have its distinct shape of grain sizes, shape of grains, and it will have its distinct density and hardness. In some cases, when we move into the midwinters, we also see that some of the snow, it starts introducing liquid water because of some melting. So because of all these processes, each of the layers, they have their distinct properties. And understanding the properties of each of these layers is very important when we try to analyze processes such as avalanche vulnerability. So let us see, for example, this image here, which shows an arrangement of different types of layers. So we can see that the term avalanche vulnerability from the snowpack develops, for example, in various cases. In this case, we see that the top layer is, for example, loose snow or fresh snow, but it is lying over slack flow plain. So this is where, it has highly vulnerable for movement because of some wind action, because it's very loosely connected to the subsiding layer. Now, underneath this, we have some hard ice layers, for example, fern, where the air percentage is very low. Then again, at the bottom, we see that there is a depth hoar. So a depth hoar basically refers to a snow layer where the snow grains, they are like sugary crystals, which crystal sizes are larger, grain sizes are larger, but they have a lot of air in them. So it's more like a fluffy, kind of a snow. And because this entire hard ice mass here is standing over this fluffy snow, it's vulnerable for fracture. So any gap or any crevasse that happens here can lead to the entire upper portion falling off or sliding off. So we can understand here that the understanding of the snowpack is very important for analyzing avalanche vulnerability. So this is an example where you can see the different layers of the snow in a snowpack, and how usually a depth hoar would look like. So there are two very important components when we talk about avalanche mechanism. The first component is the stability of the snowpack, and the second component is the stability of the slope. So we know that because of higher slopes, whenever we move into higher slopes, the mass of the ice that is traveling from the top of the mountains to the bottom, it gradually increases at the speed when it moves downwards. So any inclined snow with or any mountains which have a very high slope are more vulnerable to avalanche and ice flows. So we know technically avalanche is basically a sliding of snow mass from the top of the mountain. And we know that because of the slope, as it moves down, it picks up pace. One of the important factors here is the slope and the gravity of the mass, which contributes to the flow rates. We have different types of avalanches. For example, slab avalanche, where we have where the snowpack, it appears in hard form, and cracks appear in the snowpack, and because of that, we can have chunks of the snowpack falling down. Then we have something called as GLOF, which are usually very small in number. They cover very small areas, and this is the case of loose snow sliding down. For example, in the previous on my previous slides, we saw that loose snow lying on a quid plane. So then we have wet slides. For example, when a fresh snow or a slab is lying over a wet snow area, so it's more vulnerable to sliding. In the present case, we have an hanging avalanche, which was very well depicted by Professor Sinha, I think, in all of his images. So let us talk about how remote sensing now helps us out. So presently, remote sensing has mostly been used for avalanche zonation. So that is developing an understanding of where which are the areas most vulnerable to occurrences of avalanches. So in this case, what we do is actually we try to map events that have occurred in the past, and we try to update these records by mapping newer events. So the idea behind mapping is that it gives us an idea about what could be the conditions in which the avalanche could have occurred. And it also gives us a record where in future avalanches might occur. So both of the things, for example, for the forecasting, I think monitoring as well as updation of records, both are very important aspects. So fundamental approaches in avalanche mapping are based on change detection, basically. So where two very high resolution images, one post avalanche and one before avalanche, we take the difference of these two images and perform classification and segmentation. So these are some of the very older techniques. And unfortunately, because we have extensive cloud covers in winters, so that restricts or constrains our applicability of optical data for such an analysis. Moreover, whenever the size of the avalanche that occurred, that could be actually detected, it depends upon the spatial resolution of the satellite data that we are using. So for example, very small avalanches will not be detectable in, let's say, a sensor, for example, like MODIS, which has spatial resolution of 100 meters. However, very large avalanches, it would be possible to get some information regarding those using very coarse resolution data. So this is an example where in a study, Landsat 8 was actually used for detecting some of the avalanches. So one of the important factors here is that with Landsat 8, we have the possibility of reducing the spatial resolution to 15 meters using pan sharpening. So at 15 meters, it's a much better way of analyzing or finding out where avalanches would have occurred. But the problem again is that this interval is that Landsat 8 is available at every 14 days, and that's a very long duration. Now, because of the all-weather capabilities of the radar has been largely preferred over multispectral data for the mapping of avalanches. And again, the process is very similar. Simple change detection to be able to identify where avalanches could have occurred. But then we have a problem of geometry and speckle in radar imagery. So it does not really allow us to map or depict accurately the avalanche runouts. So that is very difficult. So there are some methods where the simple change detection technique has been improved by employing multiple channels. For example, the case study of Sentinel-1 where an effort has been made to improve the brightness of the pixels so that the avalanche activity is highlighted. So again, having multiple polarimetric channels, it kind of helps in getting such information. So where is the problem here? Now we see that most of this mapping and updation of records is usually done after a post event, but we don't have indicators or a system where we can actually predict values or provide probabilities for vulnerability. So what we need is a comprehensive system that provides probabilistic forecasting. And how we can achieve that? By using multispectral integration, multi-sensor integration. So this requires two things. One is a perfect or appropriate calibration of space-bound remote sensing data using field measurements to develop an understanding of the snowpack stability, which is very important. The other thing is meteorological parameters. So we know that wind speed is a very important parameter in driving avalanches. So we saw that in case of loose snow avalanches, the wind activity is very crucial. So in the case of snowpack stability, how we can determine that? So for example, we spoke about wet slides. For wet slides, it is important if we are continuously monitoring the snowpack to identify which are the wet snow areas. So in literature or in radar, in radar terms, in radar remote sensing, there are several methods where you could identify the wet snow. Now, another important factor here is identifying layers which contain depth hoar, for example. So that means you can derive density, and if you have information on the grain size, for example, then it is possible that you could differentiate between the depth hoar and fern, for example. So in this case, with grain size, I don't mean the multispectral grain size index or the hyperspectral grain size index. So what we need is we need a grain size for the entire volume, or at least some indication of for the volume. So this is only possible using radar data, but unfortunately we have very limited exposure to or methods or studies that provide us information on grain size using radar data. So the other important parameters that are critical for understanding snowpack stability, they are the density, the liquid water content, and the periodical depth of the snowpack. So besides this, we also need information on parameters such as the surface temperature, the wind temperature. The surface temperature is mostly available from a lot of resources. For example, Landsat data. Now we need information, all these parameters basically to assess the vulnerability of the snowpack for mass erosion that can happen because of the high wind speeds, because of the weight of the snowpack, because of any fractures that could develop because of the presence of depth hoar, or because any or sliding of any upper layers over a wet snow layer. So in our case, in using remote sensing, we have a lot of methods which have depicted or delineated accurate determination of these parameters. So for example, we had methods for determination of wet snow based on Sentinel-1 data. It's a very popular method, and it's very simple and very precise as well. So if we know the wet snow, and if we have some some information regarding the snow cover area, we can get information on the dry snow as well. With radar data, it's not possible actually to get any information regarding the dry snow, because in that case we don't have any backscatter from the snowpack. So in the case of fresh snowpack or completely dry snow, which has a lot of air percentage, then the radar signal is completely the snowpack is completely transparent to the radar signal. So radar signal penetrates through the snowpack and reaches the ground surface, and from there the scattering happens. So it's not possible actually to differentiate between your snow-free land and your dry snowpack. Now, all the so this is what I just explained here. So in the case of the snowpack, we have three interactions. One is at the air snow interface, another one at the volume, and then the third interaction at the snow ground interface, which happens when the entire snowpack is extremely dry. So in case of a moderate snowpack, usually with some water equivalent, let's say 20 millimeters, the signal will penetrate through the snowpack and terminate within the volume itself. So such such cases, in such a case, it is possible to retrieve information regarding this the intermediate layers. So with fully polarimetric SAR data, we have several methods, to define or to determine quantitatively the density and the liquid water content of the volume. So most of these methods, I don't want to go into detail here, but these methods are based on two phenomena. One is the transmissivity of the signal, and another one is the reflection of the signal. So when we speak about the dry snow or the density of the snowpack, we want to look into how the signal has been transmitted. And based on that, we can define what is the density. And when we speak about a wet snow, we know that most of the signal, radar signal, will get reflected from the surface itself. So in that case, we have very high or surface scattering power. Now the problem here is that all these methods, they are based on fully polarimetric SAR data, which is very expensive, and it's only available on demand. So by expensive, I would like to mention that one tile of such a scene, it costs about 3.5 lakhs to 4 lakhs. But we have a very fantastic resource, that is RESAT-1. It is compact polarimetric, so so limited capabilities. And unfortunately, there's not sufficient exploration with RESAT-1 regarding such kind of studies. And besides that, we also need information on meteorological data, as I mentioned earlier. But again, we have several resources for meteorological data like wind speed and so on. What we need is, we need some methods, some concrete methods which could be utilized to downscale these data sets from the resolution of kilometers to few meters. Obviously, this would require having more field information. So another very important term is glacier energy balance. So the question is, could this glacier energy balance, which is researched a lot, you will find a lot of researchers working on glacier energy balance. So could it be useful for determining the vulnerability of glacier bursts? So obviously, this is a very crucial information. The energy balance provides a very crucial information in the prediction of melt-driven steam flow, snow melt-driven steam flow. So any anomalies in the energy balance could be indicators for glacial lake outburst flows. But again, for this, remote sensing plays a very important role. So using a combination of field inputs as well as remote sensing data, it's possible to determine the energy balance for a glacier, and then analyze the anomalies to derive possible indicators for GLOFs. To summarize, no remote sensing data at a regional scale is continuous. So we are always looking in ways to fill the gaps within the two acquisitions. Then we are always dependent on supplementary field data, and we have to really thank people who are going there on the field and helping us out in whatever way they can. And the most important thing is we need to continuously observe to get any information or derive possible indicators. So this is where I'll finish my talk, and I hoped, I've shed some light.
Thank you, Dr. Varade, for giving a wonderful, lecture on you spoke about a lot of things like debris mapping and the fundamental approaches. You spoke about you spoke about the spatial resolution. But what I tried to understand, that you spoke about remote sensing satellite data, and you said that 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 about that Landsat 8, which is one of the remote sensing satellites. Just wanted to know whether you get the real-time data or, and what are the special resolutions which are regarding to that. We'll come to the question answers, after all the presentations are finished, and it was really wonderful to know about the radar systems, about the snowpack densities from your, presentation. Thank you so much. Is Rubab there? Rubab want to add something? Is Rubab there? Okay, so what we'll do is that we'll continue with the next presentations, and for that may I now request Dr. Varun Dutt and Associate Professor from IIT Mandi, and Dr. Uday Kala, who is also Associate Professor from IIT Mandi, to speak on the next presentation. Let me give a brief about Dr. Varun Dutt. He is an associate of the School of Computing and Electrical Engineering and School of Humanities and Social Sciences at Indian Institute of Technology, Mandi. And he has done his PhD thesis focused on answering the questions, why do we want to defer actions on climate change? And he has investigated the questions by applying literature on people's risk preferences, time preferences, social cultural dilemmas, and linear thinking. So he also serves as a senior member of IEEE and as the principal investigator at Applied Cognitive Services Lab. He is currently also serving as associate editor of Frontiers in Cognitive Services Science Journal. Thank you. I hope Dr. Varun Dutt is there. And let me also say about Dr. Uday Kala. He is also an associate professor. He has done his PhD for cracking characteristics of fine-grained soils for Department of Civil Engineering, IIT Bombay. He has completed his MTech in 2008 in Geotechnical Engineering from NIT Warangal. Welcome both of you, and we look forward to your presentations. Over to you.
Thank you, Mr. Majumdar. Thank you for the warm welcome, and welcome to all the guests and dignitaries present. So I just want to share our slides, and if you could confirm whether you can see our slides. Are you able to see our desktop?
Yeah.
Okay, maybe we can make it full screen.
Yeah.
Okay, so thank you for the welcome, and we'll just get started on this. So mostly our presentation will include some work on civil engineering, which we have been doing related to landslide monitoring, and also on developing these early warning systems for landslide monitoring and warning, particularly for soil movement monitoring and warning. So I'll first let my colleague Dr. Uday start the presentation, and then I'll take over as well.
Thank you, Varun. I hope all of you are having a good time. Good amount of presentations as well as the information has been coming out from the presentations which we were looking from NIDM. And here we are trying to give our part of the work which we have did on developing a novel method for monitoring of slopes. So before coming directly to the monitoring measure, I think we thought that it would be good to discuss a little about how we approached or how we have zeroed into this particular method. And during this particular session, we are going to talk about the need approach, of course, a little about requirement of risk reduction. Then what is the need of the sensors? What are the requirements we needed for looking into the sensing options? Then we'll be talking about the development of sensors, followed by some monitoring as well as some predictive analysis as a part of this particular presentation. And yes, our team, to say an interdisciplinary team, we have students who will be working, who is from electrical engineering, computer science, and also civil engineering. And we ourselves, Dr. Varun from computer science, and myself, Uday, from civil engineering, especially in the area of geotechnical engineering. And also we have some more partners, Mr. Avek Agarwal, and also two of our business manager and engineer also as a part of this particular work. So just because it is distant, all of you, I would just like to give you a glimpse of our presence of IIT Mandi in the Mid-Himalayan region, and this is one of the only institutes, or maybe IIT, in this particular arena, where we have where our campus is located in between hills, valleys. We have snow peaks and also most valleys. most river is also passing across the campus. And in the meantime, when you look into the internal part of this particular area, then we see because of the unplanned road cuts, unengineered cuts, and also the infrastructure development, we see a lot of slope failures happening in this particular region. And this a combination, as we can observe, is contains of different types of slope failures. Like we can see a joint failure in the rock, then also a major failure in the rock, and the debris mostly we can see hardly the thickness goes to not even more than half a meter. Mostly in these particular slides, probably you can see thickness is not much. So it's very difficult to say whether this is a slide or an erosion type of failure, or because, however, the mass of the soil which is coming, or the mass of the debris which is flowing from this particular location is too high or too high in order not to say it as a disaster. And this mass sometimes contains of a simple soil loose aggregate material, whereas in most of the situations we also see debris flowing out with rocks as well as different types of materials, including the vegetation which is present on this particular slope. So amounting to this, it is very important to understand that the landslide associates with a lot of issues, as well as majorly it is considered to be one of the major disaster. Till we are lucky to have it as a natural disaster, quickly it is going to convert also as a human or anthropogenic disaster. So in this, when we talk about landslides, well, most of us know very well that this is it is about the material, earthen material. It can compose of soil and rocks, as we see in some of the photographs, which moves down the slope and creates damage or disaster maybe. And this leads to life loss, almost including the issues on the issues on a lot of funds which have been lost because of to cope up with the losses associated with these landslides. And especially India having about 15% of the land covered with soils or maybe hills or mountains, so it accounts to be very high, and India tops, I think, on the line of this landslide disasters caused every year. And we have been trying our best to mitigate with this particular aspect. Especially, I'll try to take out the solution, take you all through a landslide which happened not recently. I should say now it's almost like 4 years. It's in 2017, where around 46 people lost their life. And this particular location happens to be typically 50 kilometers from IIT Mandi. You can reach there in another 1.5 hours or something. And we have seen that this has the catastrophe of this particular failure still runs across the veins in district administration here, because of which because of the life loss associated with this. So overthinking, when we look into the landslide issue, then of course we could have definitely stopped this problem, and this problem would have been attempted if we attempt to go for some risk mitigation measure. Then it can consider of two we can here. One is structural mitigations, where we are constructing something like retaining walls or anchors or nets or anchors, etc., by which we can be able to increase the stability in the soil, and thereby we can control the issues of landslide. And non-structural measures, where we have different types of approaches, either by giving rainfall thresholds, one which has been demonstrated recently in Kerala, and definitely one of the major work which goes on as a part of the disaster management in India also includes the field scale monitoring by using different types of sensors. So just before we go to the further on the monitoring, I just want to update on what are the type of the structural measures are present for landslide mitigation. So first, of course, is the engineering cutting of slopes. It includes huge lands and proper construction, which is definitely impossible or maybe very near to difficult. Sorry, it is very difficult and definitely need to impossible that we will be able to go for such a vast of construction, as well as time and materials which are involved as a part of this particular process. So just to cater with it, we try to construct some retaining walls, which are active measures. They are going to stop, or they are going to resist the failure happening in these particular locations, followed by some other methods such as nailings, anchorings, anchors, etc., which can be used for, which can be modulated, or which can be used for controlling the slides happening in these particular locations. For sometimes it is very difficult in few of the locations to stop such happening, especially in the loose boulders or maybe to the higher levels. So therefore we go for measures like passive measures such as nets, where we allow the soil to fail, but we don't allow the failure to reach the road level, and we thereby control the disaster associated with this. Similarly, barriers, where we control the rocks falling typically we go for shortcutting or meshing. I put it in passive because this is going to control the water getting into the slope. However, if the water goes in, again, there is a good amount of chance that the slope fails. And lastly, coming to the early warning system associated with putting on sensors and making it reducing the life loss associated with this particular disaster. So that's why I term it as one of the measures for disaster risk reduction. And of course, if you want to if you are looking for remedial measures, then we have two major options. One is proper drainage system. If we can allow proper drainage system, if you can allow drainage on the soils. Sorry, the photos are not visible. And the last option we have is the bioengineering, that is by having plant or plant roots, different types of plants and plant roots, by which we can control both the drainage as well as the improve the stability in the soil. You can see a very steep curve, this very steep slope, which has been supported by vegetation, which is now trending in most of the parts of the world, which we call as nature-based solutions for landscapes. So looking at this, as we go ahead, most of these measures which I have shown you includes huge construction as well as putting in or disturbing the strata of the soil. So while most of these measures are very costly, we are looking for an option of having early warning in order to control the life loss or the mitigating the risk associated with this particular landslide. So looking at it, when we look at the existing literature or existing methods which are already present or which are used enormously in the earlier situations before say 2018, then we look into a lot of methods like GPS method, LIDAR method, UAV method. I'm sure most of you would have gone through a lot of literature or at least gone through some news articles associated with such type of measures. However, most of these particular measures are very robust, I should say. Typically, when we look about the satellite methods, then it only covers a huge slide, whereas a very typical location like Kotropy, which I showed you, is difficult to be noticed from a particular satellite, and the movements are also very tedious. And when we go for the conventional geotechnical landslide monitoring systems, then it is very difficult to keep up to them, and they able to be constructed in such hilly locations. And most important, they are very costly. They end up in somewhere near 2 crores of rupees in order to go for a one particular sensing type. So this has given us a option to look for low cost landslide monitoring, which we could achieve by using the recent developments in the MEMS based sensors. MEMS stands for micro electromechanical systems, or we can also tell them they are sensors which can be used. So for looking at this particular location, we thought that it's not directly which type of sensors to be used, what are the monitoring parameters to be and all. So we thought that we should be going on for a typical study. So that's why we have selected our own area, that is Mandi Kaman, where we are happen when you travel from Mandi bus stand to the Mandi bus stand to the IIT Mandi campus. So that is why we could select this particular area as a study area, where we could collect soils from different places where we also had landslides earlier, and also the places which are not prone to landslides. So the major purpose of this particular study is to understand which of the soil parameters were giving us a site of happening of a landslide in this particular location. So we collected about 82 samples, out of which around 58 were the soils which are obtained from the landslide locations, whereas 28 are the soils which we obtained from, 22 soils which we obtained from no landslide location. So we collected all the basic geotechnical properties. We can see simple gravel content, sand content, fine content, different sizes of the particles. Then we also talked about the plasticity characteristics of the soil in terms of liquid limit, plastic limit, saturated density, moisture content, optimum moisture content, porosity, saturated density. And we also collected some information from the site, including the in situ moisture content, the relative compaction, the elevation and field slope from DEM maps. And lastly, we also found out the cohesion and angle of internal friction by bringing this undisturbed samples to the laboratory. So the major purpose of this particular study is to understand what are the causal factors, or what are the parameters which are indicating the chance of happening of a landslide at a particular location. So when at the end of this particular characterization, we found around 22 parameters from almost like 82 locations. 82 locations, as I told, around 58 of landslide locations and 24 no landslide locations. So that's why we have got into use of machine learning in order to identify the factors corresponding to the failure in this particular region. So a simple machine, we followed a small algorithm in the machine learning where we try to identify, we try to take out the factors, and we have divided them into testing and training, training and testing. And by using various of existing machine learning models, we also try to use ensemble models, and we try to find out what are the major factors which are indicating the chance of happening of a landslide. Then by using CFS, that is the contributing factors method, we could understand which of these identified methods can be used for developing a simple landslide hazard indicators. So looking at it, we performed the machine learning technique, and we could find that the J48DT decision tree method or the random forest method, these are the two methods which we have found to be very effective in this particular location. So based on this, we started ranking the parameters which we obtained, the 22 parameters. We tried to rank them in the order, and we could find that the relative compaction, porosity, field moisture content, and angle of internal friction along with the permeability stands to be the top 5 parameters which are indicating the chance of happening of a landslide, typically to this particular area, that is Mandi. So we have seen that at a that the combination of these factors has started giving us a of the maximum possible prediction when we are looking into the first 5 factors up to the angle of internal friction. So these were the 5 factors which we have identified to be most important in this particular region to be monitored if you want to understand, or if you are looking to predict a particular happening of a landslide in this particular location. So we went to the literature and we found that our factors were not very different from what we found, what was already informed in the literature. However, the combination of these factors was not existing earlier. So we have confirmed that these factors will be definitely helpful for us to get into landslide monitoring. So when we looked into the aspect, then we thought that the field moisture content or the field water content is one of the major parameters which is required to be estimated from the field. However, the parameters which are relative compaction, porosity, saturated permeability, and angle of internal friction, these are the parameters which can be used to find out the locations of sensors. For example, if I have 20 sites and I have to decide on at least 5 to start with in this particular location, then I will be choosing these 5 parameters, these 5 locations based on the soils, based on the values of the soil compared to the with respect to these particular values. And each of the location, I will now put in our sensors, which will be including majorly the moisture content, and I will be looking at how these factors can be predicted by using again these particular sensors. So at this particular point of time, we have developed our MEMS based sensors, which has again the major part which is the soil moisture sensor, followed by other environmental parameters or weather parameters. Now I request my colleague Dr. Varun to continue presentation from here. Mostly we'll be talking about the monitoring and how we approach monitoring, and now we'll be continuing how this monitoring has been used for early warning generations. Thank you.
Yeah, so thank you, Uday. So as Dr. Uday was talking about that structural and non-structural, so here we are in the non-structural measures, and mostly the idea is that we can monitor soil movements, and also we can warn people, or at least the community, about an impending disaster. And by doing so, we could evacuate or we could save some lives. So here, as you can see, there are a bunch of sensors which we have developed, and some of them we are using off the components off the shelf. Things like an accelerometer, rain gauge, moisture sensor. This is a force resistive sensor, piezo force sensor, which allows us to measure soil stress. And then a bunch of sensors which allow us to do measurement of weather parameters, light, humidity, and then there is a connectivity module as well. So using some of these technologies, and of course the ranges of these technologies are given. And one other thing is this accelerometer actually also has a gyroscope in it, so it can measure rotational motion. So first idea was that when we have a bunch of sensors, we need to do something to get confidence that these are able to do things in the field. So how do we get confidence? We get confidence by doing things in the lab. So first of the set of studies which we started performing in about 2-3 years back were actually lab-based studies where we studied the moisture sensor inside a beaker with soil in it, and then try to see whether how good it is to measure volumetric moisture content in the soil sample. And then from the laboratory, we went into a thing like a small, you can say, in between setup. It's a ramp setup where we can pack soil of different kind, and you can see a pipe going inside, and there is actually a bunch of wires. So there is actually a sensor packed there, and this is actually an inclined plane. So you could actually pour more water into it, and it has a a computer setup where values are coming, and then we can create a controlled you can say mudslide or a soil movement. So when we do that, as you can see that in this case the gate was opened and the toe, and then the thing collapsed. So we were able to record the change in the accelerations happening over time, and this may of course happen over a period of a few seconds. In this case it happened over a few seconds, 10 seconds and things. And this measurement started giving us confidence that the technologies which we were using are capable of doing what we are trying to do in the real world. So then we led to design of the LMEWS is basically the landslide monitoring and early warning system framework. And here in this framework, we have, as you can see, a sensing unit, which is mostly sensing, consists of sensors of different kinds. Some of these sensors are soil sensors, which measure moisture in the soil or movement of the soil or force in the soil. And some of them are weather sensors also, which allows us to determine weather parameters, including the amount of rainfall happening in that location where it is deployed. Then we have a data logging and thresholding module, which allows the sensor values to be sent to a cloud database. And there we can do analytics, we can do thresholding, we can actually analyze the data as it's coming in real time. And that may lead us to generate warnings. Warnings can of course be generated locally at where the deployment is, and also globally using technologies like internet, mobile, and others. So of course we have filed patents and other things on this setup, and this is actually this setup is a low-cost setup. It doesn't cost too much of amount of rupees to do this. So here is an example in the field. As you can see, there is a tension crack in the soil here. So we are right on top of this hill. You can see this is me, and this is, I guess, Dr. Uday here. And we have some students here. We are right on top of a landslide. And if you look at from the top, this is what's going on there. So you can see that the soil has started to separate from the mass. And what we are doing here is we are putting these sensors right here in this part. You can see these wires are going into the soil to actually see. This is basically the bunch of accelerometers put here. And this is very preliminary setup where we actually didn't have any rigid or rugged casing. So we just took a plastic box, bought it from the market and put things in. And you can see the electronics, and this was deployed. And we started getting values. And you can see we started getting values every 10 odd minutes. And of course, the values contain temperature, humidity values, the pressure value, rain value, and a bunch of acceleration values, which is a vector quantity. And this is in G units. So basically, it's nothing but the gravitational acceleration, which has three components, Gx, Gy, Gz, and then the omega values for rotation and some angles as well. And then we could also get some force value, which is soil stress, and the moisture in the soil. So we could also plot this graphically, and this is a real-time system which got created. So how do we do this? So of course, there is no rocket science behind it. The idea is that acceleration is actually something which is rate of change of velocity. So if we integrate acceleration, we will get change in velocity. And if we integrate change in velocity, we will get displacements. So when you get a bunch of displacements, and the idea is whether this displacement is really worrisome, meaningful, shall we do something about it? So places like here, like Kotropi, Diod, Hanogi, where we are, there is a message coming almost every 2 days. There is movement happening. So shall we be worried about it? So the idea is, how do we know? So one way of doing it is to impose some kind of distribution on the set of movements happening. And one idea is to impose a z-score, or typically a normal distribution. And the idea is that we kind of have an estimate of the mean movement and the standard deviation in the movement. And then we can find the difference between the current value and the average and find out what percentile it is. Means typically a z-score allows us to, on the normal distribution, allows us to quantify a percentile, right? How outlying this value is compared to the average value or the standard deviation. Is it 1 standard deviation, 2 standard deviations, somewhere ahead of the mean or so? So we could do the same thing on rotation as well. So we could do it on movement, we could do it on rotation, and based on these we could come up with some thresholds. Some thresholds could be that if it's like the 70th percentile, we could raise a small alert. If it's an 80th percentile, a large moderate alert, and then 90th percentile, 95th percentile, really very far away from the mean, could raise a serious alert. So all this has been done already. And once you do this, this is a location where we have this system deployed in Nainital. And this is Balia Nala, another famous landslide, and a lot of movement there. And as you can see that these movement messages start to get triggered. And in these movement messages, we give, of course, two things: a small soil movement. So see, the layman will not understand the 2 centimeter or 2 millimeter or 0.2 millimeter. So the idea is you could give some kind of, an English word which can say whether it's really serious or not. In this case, it's a small movement, and you can see that the small movement is tagged with the location where it's happening. And also it says, watch out for potential landslide. Now this is small, this is small, this is small, this is small, and this is moderate. You can see actually this is all happening within 1 hour of time. So what's telling you is that, what you see at the end where that big mass falls on the river or on the road, that doesn't happen all of a sudden. There are small movements which actually start to take place, and then suddenly it is followed by a moderate movement or a large movement. So things start moving, and our system is able to detect very small movements, actually movements as small as 0.3 mm to an extent. So so this is just an idea, and these are actually messages which have come on my mobile phone and also mobile phone of the district administration and PWD in the area in Uttarakhand, where they are able to see such kind of messages coming in real time. So how does the system look like? This is how the system looks like now. And of course, we have also done a little bit of fine tuning, but the idea is we came up with this idea that we need a solar panel to be able to energize the system, because relying on grid connected power, and especially in areas which are remote like hills, is a doom, because you don't find electricity, and even if you find electricity, probably power is the first thing to fail in a disaster. And the other thing is that we have a rain gauge right here, and then we have a bunch of these wires you can see going down, and these wires are actually inside the soil, and these wires are the same wires which I showed you a close-up on the tension crack where we were trying to measure movement. And see, we have buried this system inside the soil itself, so it's like, and this is typically made of mild steel, so even if it goes down with the set of things, mostly the box contains the electronics, where we have a logger and other things, which is all made on our campus. And also one small antenna is right here, which is sending the data out to the internet. Now we have a bunch of connectivity options. I'll just explain. One, of course, is to rely on mobile communication. Another is to store data within the box itself in an SD card, like a black box. And the third aspect is you can even connect to Wi-Fi. And if you don't have anything, you want to set up something, we can even set up something using radio frequencies. So this kind of tower is mostly on a hill, and there are a bunch of such deployments depending upon where it might be interesting to observe movements. And then this system is sending data to a cloud, using internet, where we are doing the thresholding and learning and machine learning and data analysis. And then we are triggering warnings on mobile phones through SMS and also on tablet computers. Now, why SMS? Because we found that even in Himachal Pradesh, where we live, the penetration of the smartphone is about 60%. So still 40% to 35 to 40% people still have what you call Symbian phones, the button touch phones. And so what is the least common multiple? That is SMS. You can receive an SMS on a Symbian phone. The same time, you can receive an SMS on a smartphone. And we can also create such alerts on a website, and we can even send email if you want to a person who likes email. Anyway, so coming back, now these are the houses here. And if a slide is happening, these houses are to be protected. So what do? We actually set up an alarming system here. And this alarming system is connected to the tower, depending upon, of course, I could put a wire, but the wire is actually a very untidy solution and is prone to getting damages, cuts, bitting, and because there might be animal intrusions, there may be weather intrusions, there may be somebody getting tripped on the wire. So we have set up a wireless system based on radio frequency. So typically the alarming pole locally is connected to the unit. And here we are using radio frequencies, very modern technologies like LoRa, where we can actually increase the range depending upon the line of sight. Sometimes this thing is actually blocked by houses or trees. So we have to put repeaters and then we bring it here. Okay, so coming back, so this is how it looks like. This happens to be one of the active landslides. I guess this is the Kotropi landslide. And we are right, as you can see, one of our staffs, Ankush, is right putting the system. This is the same place where 46 lives were lost in year 2018. And this is how the system looks like. This is how the sensor goes into the sensor node goes into the soil, just going through. And this is how the warning come here. The warning is actually from deployment in Sirmor. And then we have also the ability to observe things graphically and also on the map. So of course, we don't stop there. See, the idea is now we start getting data from so many locations, and there are so many deployments. So can we do something about it to become more intelligent as to pre-warn people even before movements happen? So we started doing this. We started doing data analytics on data collected from our own systems. And so we had deployed a bunch of systems in Mandi, Himachal Pradesh. And we took data from 5 such systems. And you can see that 80% of this data was used for training and 20% of this data was used for testing. Of course, we tried a number of different algorithms, machine learning algorithms, including the statistical ones, you can say classical ones, and more deep learning algorithms. And one interesting algorithm which we have tried is some combination of neural networks. And we have tried it with univariate and multivariate data. So univariate basically means we are using movement to predict movement in future. And multivariate means that we are predicting movement in future using movement of past, but also of other variables like rain, like the soil properties and other things measured by the system, including weather variables. So so what we are doing is that here, particularly in this particular case study which I'm showing you, we have a neural network model which is built on predicting each system's movement. And we have 2 flavors, univariate as well as multivariate. And then these models all give their predictions, and then they feed their prediction to a global model, which is taking values from all the stations in a certain location and then generating a final prediction. So we have been able to do this, and this is just an idea of how good the model is, or a set of models are. So you can see this is actually the data from one of the systems deployed in Mandi districts, station number 6, just telling you. And this data is typically during the 2018 season, the rainfall season. As you see, the data starts around the 9th of July, when typically the monsoon set in. And there are two trajectories here. The blue curve, which is the actual displacement, and we have the red. Thank you there. And then we have the red curve, which is the predicted displacement. So as you can see, this predicted displacement, and what is this vertical line? This vertical line, this is the training data and this is the test data. And see that the model is doing reasonably well in predicting movements in soils in centimeters, which are, so it's doing relatively well. And this is a big spike. This is a major movement of more than about a centimeter, which has happened, and in that location, in that station, and maybe triggered by rainfall and other events. So just to show you that using multi-layer perceptron, very simple ideas, we can actually get to predict landslides, or at least not landslides, but if this could be a slide, let's say, but let's say soil movements. So, okay, so this is actually our T8 station, and I think this is the Kotropi station. And it's interesting to show you this part here in the Kotropi station. This actually happened to be a flash flood, which had happened. So the actual disaster in Kotropi happened in 2017, when 46 people were lost. The next year, there was an interesting kind of situation. A gush of water came suddenly in that Kotropi area, and there the system actually and that day, of course, there was a lot of movement in this part, and this is where the system came online, and we alerted the district administration. The warning poles came online, traffic was stopped, and the road was washed. So if the traffic was going on that road, which happens to be this Mandi Joginder Nagar road, it would have washed again some cars and traffic, and it would have led to loss of lives. So what I'm trying to say is that even in major landslides like Kotropi, we have been able to show, and then we took this data and then we were able to also do predictive modeling. So this year we are trying to actually integrate. We've been actually cooking this for some time, and this year coming monsoon, we're planning to actually give real-time predictions to the district administration, directing their attention what they should be doing next day. Of course, we could do this in several locations. Yeah, and this happens to be Kotropi, another station, and as you can see, we could do this across different stations. This is a single model predicting, taking ensembling of individual models for each different station. Okay, so here we have the district commissioner, Mr. Rupdev Thakur, talking about our system, and we also have some movements. This is basically, I was trying to show you a blow up of the Kotropi case, where significant movements happened on the 27th of July 2018, and we were able to avert at least some losses. Been covered in some media, and we also started a company recently, Services Private Limited, to actually see, we are an IIT, so we do research, but if somebody comes and says we want to buy so many systems, we cannot sell because we are not like a shop. So it's like a startup company which is led by Dr. Uday Nai and as part-time directors, and also our students who have actually been working on their masters and research work, now leading the company. So as you can see, we have done several kinds of installations in Mandi, Solan, Nainital. We have recently been working with railways now. So we deployed 3 systems along the Kalka Shimla railway track at Dharampur. This happens to be a deployment on that heritage railway, very old, and we are modeling railways about this. And then, of course, Make in India is there. We are doing things using our own, even the rain gauge bucket, the basket is something we buy in the Mandi market, and it's actually a small plastic basket. We cut the hole, but we measure the dimension and we are able to calibrate it to see if it measures the rain properly. And we do that testing in the lab here. So, so we get data of different kinds, soil properties, movement, rainfall, And we have a potential of doing this thresholding and learning in future. So I'm just going to show you some pictures of deployments. This is the deployment we have done with Indian Railways along the Kalka-Shimla track. And as you can see, there is actually there is a national highway passing. And this is the reinforcement, and there's a crack in the reinforcement. Railway says, okay, we can see that your system is doing landslide monitoring. Can it do this crack monitoring? And okay, of course, this is a crack in the cement. And we've been looking at the tension cracks in soils, and we said we can do that probably. We've been able to deploy this, and it's actually been deployed just on the crack right here. And we've been able to do it. Recently, we've also developed a low-cost extensiometer solution using potentiometers, and this is again proving to be good. So we're using basically wireline extensiometer for measuring very small movements, and that actually is installed along with the accelerometer to actually check for false alarms. This is the deployment I was talking to you about. Another place, and this is a third place. They have done some Gibeon work, which is Dr. Uday is the expert here for structural monitoring. Okay, so we've also recently received a big order from Himachal government with our success on deploying these systems across the Mandi district. So 20 such systems probably, and we are going to go at about 6 to 7 per year. And we are looking at locations within Mandi district, which include places like Kotropi and others, and also some routes which become activated when actually the main roads are blocked because of flash floods or because of the river rise. Bias River swells up during the monsoon season, and that causes the national highway between Pando and Aut to get affected. So we have alternate roads which are also used to go to Kullu Manali, and those roads also suffer landslides, but we don't have any monitoring on them. So we could do that. So there's some other interesting things we are doing. Recently, Konkan Railways contacted us that they are interested in trying the system along the, so this happens to be the Padi Tunnel in Goa, place where you can go and have fun, but it's also affected by landslides. And this tunnel is actually a very interesting thing. It's actually about 1 kilometer long tunnel. Luckily, it is a straight tunnel, and there is a watch cabin right here, and they have actually constructed some berm here to protect this, but you can see it's a virgin slope and prone to slide, and it's actually quite big, and it's right outside the mouth of the south mouth of the tunnel. And north mouth also has a problem, but so they are looking at south mouth right now. One interesting thing is that see, this track, the train goes at 120 to 130 kilometers per hour, and to break the train at that speed with that much of momentum, mass into velocity, is almost 1 kilometer of stopping distance. So it takes the train to stop. We have to stop the train right before the slide. You have to start stopping it 1 kilometer before. But 1 kilometer before, there is a tunnel, and how to take the warning pole inside wirelessly inside the tunnel, cross the tunnel. So there are some other interesting signal losses are there, and we're working on this problem and hoping that we have tried to test the solution on our campus. Once we get a go ahead to do it there, we're going to try it out there, as we have been able to take a signal from our north campus to south campus over 5 kilometers here. So this is another interesting deployment which is coming up. So recently, Transport for London Underground contacted us in UK. Unfortunately, COVID has been a spoiler, but we are working with them as well. And this is the Croxley station, and there is actually a lands. Actually, this is the from the top. There is this area is actually prone to sliding, and this is a railway track. This is the London Underground track, and we have thought of putting these warning poles here, and we are working with them. As in when travel is possible, we will be able to go and do a pilot there. So we've also won some awards, state award for disaster risk reduction, and patents and other things are there, some of the publications and some media coverage, and I'll say thank you. Uday, you want to add something before we end?
Thank you.
So we can ask if any questions are there, and just.
Thank you, Dr. Varun sir, for a wonderful presentation. Thank you, Dr. Uday Mishra, for a very wonderful presentations talking about the structural measures and also about the existing landslide monitoring technologies, the conventional geotechnical landslide monitoring methods. You also spoke about the type of sensors and the wonderful thing how the sensors can be used. So it was really wonderful. We'll take up the question answers after after the presentations. So I will now hand over the mic to Rubab. Rubab, are you there?
Really,
We are losing your voice. There must be some technical problem at Rubab's side. We are not able to hear him.
I think I must congratulate you for the great the uh, audible now. Am I audible?
Now you are audible, but your voice is not clear.
Yes, sir. Could you repeat yourself, sir, one more time? Actually, we could hear you in bits and pieces. If you could repeat.
Am I audible?
Yeah, now you're audible.
Manak, can you hear me?
Yeah, now I can hear you.
I think I'm facing some technical issue. I'll have to disconnect and come back again. Meanwhile, I may request Professor Chandan Ghosh to please come in if he has any comments to make, and we can move on to the next speaker, please.
Okay. Varun and Uday, both of you have given an insight into the development, perfections, application, monitoring, giving warning, and most important is that you have shown in your last slide that you got a you got a offer rather in London where they are facing and where you are supposed to deploy your system over there. So that is, I think, a very, very heartening news that you have given at this juncture, that where in our country we are also looking for this kind of solutions, where the district collector, Mr. Thakur, has taken, and yes, he has taken such a step to promote these things at the district level, that which you are doing wonders for the country, developing the things and making a company your own, and then promoting this technology with all sincerity, in the sense of checking doing the research and checking that which are the parameters that even many of them, even you have tried the 20 plus parameters that you have tested, then which are the most important parameters that are crucial for landslide early warning, decision making in the landslide early warning, and then coming to the interface with the public and government and everyone, that giving a message to them. And not only that, this probably will come to not only simply a message, but you will bring it as an information like the way we receive, like earthquake maps, shake map, or intensity map that which comes from USGS directly, or even our National Center for Seismology. They also give epicenter and magnitude of these things after earthquake happens. So I think another step towards reaching to the public and everyone across the internet as well as community is to bring it to making this into a Google map and then triggering it through a different tune into our smartphone, the way many other hazard, whether it is volcano, whether it is earthquake, whether it is landslide, even many other things are coming in on the net, like seismic monitor, jumbo seismic monitor that it gives, or even volcano signals that they give. Many other hazards. There are 35 plus hazards mentioned in our Disaster Management Act. So early warning, especially for landslide, we see that you take the lead, and you take the lead in bringing it to our SMS, converted to Twitter, to even some location-oriented Google Map uploaded message and information. There are a number of questions are there which we take. If you allow me, then we come to you, because there are many queries as well as many interesting things are there. I can see in the chat box. But before we take up these things, I think we would, if you think that you can come back again after the end of two more presentations are there. We have from Engineer Anand Rai from CWC, who is patiently waiting, and he is going to talk about the GLOF. And it's he's the person in CWC that who have all information about the status of the GLOF in our country's context, and he is very much informed, as well as he's a I would say that he carries a lot of legacy, especially working in CWC in this area, in the very much context that whatever happened at Kapuban. And so I would request Mr. Rai to share your august experience with this regard.
Thank you so much.
Thank you.
I would, before we request Mr. Engineer Nityanand Rai ji to come up, I would like to share a few words on his to introduce him to the audience. If you allow me, okay. Engineer Rai,
please.
We'll take a quick moment to introduce you. That's also equally important, because everyone, although a lot of these are participants, we encourage them also. They look into the on the internet of what the experience that our panel of experts bring in. But for the knowledge of those who could not, Nityanand Rai ji is a director in Hydrology Directorate, Central Water Commission. He graduated in civil engineering from Kamala Nehru Institute of Technology, Sultanpur, UP, and did his postgrad in hydrology from IIT Roorkee. He joined CWC in '95 as assistant director, and since then had worked in the field of hydrological and hydrodynamic modeling. He has carried out the hydrological and hydrodynamic modeling for more than 70 river valley projects for water availability studies, design, flood estimations, dam break studies, glacial lake outburst flood, GLOF studies, backwater studies, reservoir sedimentation profile studies, etc. I don't think there is anything more left to say. I mean, your profile is your experience is so rich, and we are so excited to actually, we are looking forward to hear your experience, your thoughts on this, what has happened recently, and where we go from here as a country when it comes to preparedness to dealing with such disaster. Over to you, Nityanand Rai ji.
Thank you, sir. Good afternoon, everybody.
Share. Let me check share. Anyway, let me check.
So in this presentation, I am going to.
Just go back to the screen. Just ask whether
Mozilla. What is in Mozilla?
Yes.
This
FICC,
yeah. On this FICC. Yes, sir.
Display.
Yes, sir.
Yeah.
No, this way. यहाँ पे
So can you ask if the slide is visible?
यहाँ पे full screen कर दो यहाँ और can you ask them if it is visible screen? So ask them the
Sir,
video.
is
Yes, we
screen
can see your
visible?
slides. Yes, we can see your slides, sir. Yes, we can see your screen.
Okay, so in this presentation, I'm going to discuss about the glacial lakes and their impact on water resources projects. In Central Water Commission, actually way back from 2000, year 2000 onward, we started considering glacial lake outburst flood also while designing our river valley projects. At that time, this GLOF phenomena was not well known. So first time we analyzed this GLOF flood estimation for two very important projects of government of Bhutan, in which government of India is providing all the assistance and funding also. That is the Puna Sangchu 1 and Puna Sangchu 2 project. In that, that was the first project in which I was involved for the glacial lake outburst flood study, and after that for the different river valley projects for which DPR was submitted to Central Electricity Authority, and then for technical examination it came to Central Water Commission. We got the GLOF studies carried out for the projects situated in say Subansiri Basin, in Lohit Basin, in even Uttarakhand also, Uttarakhand projects also. So first I will give you just one brief introduction about the glacial lakes and what is the globe. So we all know that glaciers are the vast resource of water, and glacier formation process I'm not going to explain here because that is also a very big theory behind that. But melting of the glacier and formation of the glacier, this goes on side by side. That much I can say you. And because of, there is no doubt that little bit rise in temperature is taking place globally. And another important aspect, that this glacier mass is very sensitive to the rise of the temperature. So whenever, because of the average rise in the temperature, glaciers are also melting at a faster rate. So most of the valley glaciers, they are nothing but they are the moving mass of ice, and when they are moving, they erode the valley material. Like what you are seeing, this is the glacier, and when the glacier is moving along this valley, then it is also eroding the valley material, and it is get accumulated at the snout of the glacier. This is the called generally snout of the glacier, and for present picture we will say the snout of glacier is here, but here earlier this snout of glacier must have been here, and now this is moraine material is blocking the whole thing. And because now this portion is at lower elevation in comparison to this, so this ice has melted and one glacial lake formation has taken place. So this is called typically moraine dammed glacial lakes. Now we in Himalayan regions, we have Central Water Commission in association with the National Remote Sensing Agency. We have prepared the inventory of glacial lakes also for other countries like Bhutan and Nepal. This glacial lake inventory has been prepared by ICMOD also. So all those now a lot of data is available about the glacial lakes, but only knowing the glacial lakes is not enough. We have to keep when we are planning some projects, so how many glacial lakes are situated in that project catchment. So all those things that we are going to discuss how we go for LC and analysis. But one important aspect when we are planning the river valley projects in these areas, and if the DPR is being submitted to Central Water Commission, then we are always recommending that you have to study the GLOF phenomena also, or glacial lake outburst flood also, along with your design flood, and your spillway and sluices should be designed considering both floods. These are some of the findings, like ICMOD finding, a sequel of global warming causing glaciers to deplete in many mountain regions during so-called little ices, that is generally we call from 150 AD to 1850 AD. Many glaciers were longer than today, that is a well-known fact. Then moraines were formed in form of the glacier, in front of the glacier at that time, which nowadays block the lakes. Then overtopping and breaching of the dam by wave generated by avalanche or glacier calving is the most common failure mechanism. I will show you also almost more than 75% GLOF failures are due to avalanches. Even in the case of 2013 Uttarakhand flood, in which this Chorabari glacier lake, when it breached, so there were two regions. One was the very high rainfall and the lake was completely filled. And then some mass of the glacier also broke from that location and fell into that lake. And that created a surge wave, resulting breaching of the moraine dam. The sudden failure of the moraine or glacial lake can release a very large amount of water. And that type of failure, which is occurring due to lake burst of this glacial water, or that we call basically glacial lake outburst flood. So in the case of glacial, like any dam break phenomena, this glacial lake outburst flood is also depending upon these important factors. One is your lake volume, that is the what is the volume of the lake, or the total volume of the water which is accumulated behind that moraine dam. Then the dam height and width, then what is the dam material composition, then failure mechanism, and downstream topography. All these are the governing criteria, because when we are going for the even hydrodynamic routing, we can see all these impacts very well. Now, what are the different type of glacial lakes? So all the glacial lakes are not dangerous. So depending upon the type, we can classify the glacial lake like supraglacial lake. These are the glacial lakes which are forming on the surface of the glaciers. Now what you are seeing, this is a supraglacial lake which has formed on the surface. This is the photograph of one of the glacial lake of Bhutan, that is forming on the Tharthormi glacier. Now, in the second picture, what you can see, this is the Tharthormi glacier, and what you are seeing here, this is the some part of the glacier has melted, and now one glacial lake formation is taking place here. Then this is another picture. This is another glacial lake which is just adjacent to the Tharthormi glacier, and this is called the Rafstrange glacial lake. And this glacial lake is fully formed. What you are seeing, this is the snout of the Rafstrange glacier, and here the water is lake water is contact to this snout of the glacier, and when the lake water is in contact in the to the snout of the glacier, then some carving of the ice near this snout may take place, and over a period of time, suppose this much carving has taken place from below the glacier, then this much ice, it is going to act as a cantilever only, and over a period of time, when that cantilever is not able to support, then it will fall down, and that may create a surge wave, resulting bursting of this entire moraine dam and resulting GLOF phenomena. Another type of glacial lake is that is called the Syrup lake. So Syrup or Kori, that is formed at the head of a valley glacier by erosion. Suppose this is a valley glacier, and here a glacier is there, and some terminal moraine is there, and over a period of time, due to temperature changes, due to number of other regions, this glacier has melted away, and some water might have passed through that. Rest of the water will remain accumulated here. That is called the side glacial lake. Like in Lohit Basin, you can see a number of side glacial lake. Like these are the some of the Google Earth imagery of those side lake that you can see. Normal in Sikkim also, this Changu Lake, when we are going to the Nathula Pass, so there is a big lake that is called Changu Lake, and that Changu Lake is also a Cyrac type glacier, glacial lake. So generally Cyrac glacial lakes are quite stable in nature. Failure may take place for these glacial lakes, but that is not very common. Now I will show you some of the comparison of, like, because this presentation I have carried out a lot of study of this Bhutan region. So I am showing you some of the glacial lake over a period of time, how this, like this is one 1993 imagery, then 1994 imagery, then year 2007 imagery, and then we have compared how the size of the glacial lakes are increasing with the time. So, and this is what you are seeing. This is the actual photograph of the snout of the Rafstrange Glacier. So this is the site, one of the site photograph of the Rafstrange Glacial Lake. And these are the moraine dammed glacial lakes in the Siang Basin of the Arunachal Pradesh. There a number of the glacial lakes are present in the Tibet area. So these are the some of the Google Earth imageries from that area. In the Lohit Basin, like when we were going for the planning of this hydropower projects, so number of projects were coming up, like on the, this is the Lohit River. If you are seeing the number of projects like Demwe was here, then some Kalai 1, Kalai 2, and many more projects were there. And what we have found in this Lohit Basin itself, there were 269 glacial lakes, and out of that, about 35 glacial lakes were of dangerous category, means seeing the lake size and type of and this moraine type of glacial lakes, around 35 lakes appears to be dangerous that time. And what you are seeing, some of the moraine dam glacial lakes in the Lohit Basin itself. Then Tista Basin. In Tista Basin, there are very big glacial lakes. 14 are potentially dangerous category as per IC mode also. And major projects are here: Tista 3, Tista 4, 5, 6. And there are 2 lakes which are having the area more than 100 hectares. So what you are seeing, these are the some of the glacial lakes. Like these are the which are the potential dangerous category. Some number has been given, glacial lake number by IC mode also. So that number what I am saying, showing you. Then in Subansiri Basin also number of projects were planned, which are at the different stages of investigation. So here also what you are seeing, number of glacial lakes are there in the catchment area of the Subansiri River. What these dotted, what you are seeing, those are the location of the glacial lakes. All these are the glacial lake locations. Then in Subansiri Basin, like what we have measured at that time, how much increase in the lake area over a period of time has occurred. Like what we have compared this for one of the glacial lakes, which we have considered basically for the GLOF simulation. Here the lake area, surface area, it was increased by 22% between the year 2006 and 2010. So this is the moraine dam glacial lake formation phenomena, which I have already explained. Like when this glacier mass is moving, then it is eroding the valley material, and this valley material is getting accumulated just in front of the glacier. And when this glacier is coming below a particular elevation, then this ice gets melted and this lake formation is taking place. Now, what are the important facts about the moraine dam glacial lakes? This I would like to mention here. That most of the moraine dams and moraine dam glacial lakes have a history of cyclic outburst activity. Like in the case of Bhutan itself, this there is one Luge glacial lake which has already bursted 3 times in past. Once in 1972, then 1985, then again in 1990. The number of 3 times that particular glacial lakes have busted, and causing a lot of this mud flow in the downstream area, and good amount of flood also. So so they have cyclic outburst activity because they will burst, then again that formation will take place. Then as glacier retreat, the cyclic outburst activity may travel up to nearly formed moraine dam and the moraine dam lakes. Then the cyclic outburst activity ends when the moraine dam is damaged by the outburst flood to the point that it can no longer hold the water. This is very true. When the moraine dam is completely washed out, then there is no obstruction. Whatever the melting is taking place, that water is coming into the river and no glacial lake formation can take place. Now, what are the basic, we have developed methodology also in Center Water Commission ki how these GLOF we should estimate. So this is the general methodology for estimating the glacial lake outburst flood for the projects, because there may be number of glacial lakes, some 30, 35. So we are not going to do the simulation of all the glacial lakes. So we have to make some criteria ki which of the glacial lakes can be considered quite critical, or what combination of the, whether the combination of 2 or 3 glacial lakes are also possible. So that all these things we visualize, we analyze, and then we go for the GLOF simulation. So these are the steps. Identify the potentially dangerous glacial lake in the project catchment based on the location of lake, associated mother glacier, and topographic feature around the lake and glaciers. So this we observe. Then identify the possible combination of the potentially dangerous glacial lake, that we have to see whether 2 or 3 glacial lakes can combine, whether their combination is possible in future or not. Then estimate the lake water spread area and their volume, and finalize the glacial lake for the GLOF simulation after a detailed criticality analysis based on the lake volume, its distance from the project site, and average slope of the river from the glacial lake till the project site. Then estimate the breach parameter for the moraine dam and simulate the dam break flood using any mathematical model, like we can use HECRAS or Mike 11, whatever is available that you can use. Then channel route the glacial lake outburst flood through the entire reach of the river from the GLOF site to project site to get the magnitude of flood peak at project site. This becomes very important part, because glacial lake outburst flood is quite different than the normal flood. In the case of glacial lake outburst flood, what happens, your flood hydrograph will be very peaked one, but its time base will be quite small. So when such type of flood hydrograph, it passes through the river valley downstream, then a good amount of attenuation take place. And your peak at say 50 kilometer or 100 kilometer downstream or 200 kilometer downstream, it will attenuate, or you will get a quite significantly attenuated flood peak at those locations. But another important aspect of the GLOF is here the associated velocity, or the velocity of travel of the flood wave, that could be very significant. It may vary from 20 meters per second to 10 meters per second or more than something like that. But in the case of normal flood, even in Himalayan region, you can get a velocity of 6 to 7 meters per second, maximum 8 meters per second. But in the case of GLOF, velocity maybe about 20 meters per second, 15 meters per second. So that is the basic danger of this glacial lake outburst flood. Then regions for the moraine dam lake failure, melting of the ice core, this impervious ice core within the moraine dam melts, lowering the effective height of the dam. That is one of the. Then overtopping by displacement waves, the lake water is displaced by the sudden influx of rock or ice avalanche debris, creating a surge and resulting overtoppling of the dam. That is one of the phenomena. Then settlement, earthquake shock can cause settlement of the moraine, reducing the freeboard. Once freeboard gets reduced, then because of this wave heights, if some water is getting over toppling, then it is causing erosion of the moraine material downstream of the dam and ultimately leading the failure of the entire moraine dam. Then the subglacial drainage, here the volume of the meltwater within the lake increases to a point that the formerly grounded glacier floats, causing an instantaneous subglacial drainage. This can destroy any moraine dam. This is the percentage distribution of the region of the globe. The ICMOD has carried out number of studies of this Nepal and Bhutan GLOF events. So what they have found, about 75% of the GLOF are due to snow avalanche, and about 10% of the GLOF event may be attributed to the ice core moraine collapse due to melting of ice core. Then another 10% ice core moraine collapse due to seepage, and then about 5% due to rock avalanche. Some rock has fell inside the lake, created the surge wave, and then overtoppling of the complete moraine material. Here I will show you some, because when we were doing this project, we got number of photographs also. This Glogel Lake bus of Bhutan in 1994. So this is the Luge Glacial Lake, what you are seeing. And this is the Thormi Glacier, what I just described, where a number of supraglacial lake formation is taking place. And this is the Rafstein Glacial Lake. And this is another Bachung Glacier, but here hardly any supraglacial lakes are present on that surface. And there was one settlement also in Bhutan. Also, this is called the Thanja village. So this is the some partial volume was released during the 1994 GLOF, and 2 weeks after 1994 GLOF, this is the photograph of that glacial lake. You can see still a significant volume of the is still present in that Luge glacial lake. And this is a very famous place that is called Wangdu Phodrang. And here the monastery is there. This is very famous monastery of the, and here whatever the one bridge was there, which was connecting this monastery from road is this side and left side. And from here, just to go to this monastery, some bridge was there. All this bridge was washed out. You can see the piers only. And this is the condition of the flow. Matlab, it was just like a mud flow, and you can see in photograph how much debris is present in that glacial lake. And this is the near the one of village is there, Lendi village. And here you can see what was the condition, how much debris was deposited. Even in the recent this Rishi Ganga, this landslide and snow avalanche, what happened just 1 week before, we can see so much debris is there. So in such type of events, a lot of debris is also coming. So, and even the flood, whatever the flood is coming, that flood phenomena is flowing in the river like a mud flow. So that is one of the peculiar property of the glacial lake outburst flood or landslide dam, or if the avalanche is taking place, a very higher elevation to lower elevation, where just coming down the complete ice mass get melted because of the temperature difference, and then it converted into flood wave. So in that type of events, a lot of this sediment concentration, like number of such type of events occurred on Nathpa Jhakri project also. And here the sediment concentration may be of the order of your 30,000 ppm to 80,000 or 90,000 ppm, that you can imagine. While in the normal flood, it may be something around 2,000 ppm, 3,000 ppm. So that is a basic difference of the GLOF flood and the normal flood. Then this I have already explained, so I am skipping this. But here what you can see, like here for the 3 glacial lakes, what we have compared, this is the time series. So up to 2007, when we carried out this, when I was making some study, then I carried out all these analysis. So in 1993, like in Rafstein, it was almost stable 127, then in 1994 130, and in 2007 128. So this glacial lake is almost stable. But you see on the Thormi, this supraglacial lake, they are increasing in the size. In 1993 there was no supraglacial lake, but in 1994 one supraglacial lake formed. Its area was 41 hectare. In 2007 it is 88 hectare. This, after the GLOF event, this Luge was, its surface area was, earlier it was in 1993 118, but after the 1994 GLOF event, its surface area was only 96 hectare. Rest of the volume was passed away in the downstream valley. And in year 2007, again, now you can see this is 127 hectare. This is a really very big glacial lake. So what we carried out, how we carried out this, so I will just give you some idea of how this GLOF simulation we generally carry out. So generally we mark the location of the project, and then we just see how many glacial lakes are present. And then we see all those glacial lakes, we see their inventory. Then we carry out a detail, like what you are seeing. These are the different potentially dangerous glacial lakes in the catchment area of this project. So that we have considered. So out of total 667 glacial lakes are present in that basin particularly. Out of that, there are 13 potentially dangerous glacial lakes. These potentially dangerous glacial lakes have been declared by ICMOD and Bhutanese government also, based depending upon the lake parameters, how the lake sizes are increasing over a period of time, what type of topography is there. So based on that, they have classified these 13 as potentially dangerous glacial lakes. And these are the lake numbers which we have given, the same lake number what has been given in the inventory of the glacial lake prepared by ICMOD. And what this is the latitude, longitude of those glacial lakes, what is their altitude, what is the length of the lake, what is the width of the lake, what is the surface area. And then they have given some formula also, because this ICMOD, depending upon the surface area, they have given, because they have carried out measurement of the different type of glacial lake. So for Cyrock type of glacial lake, they have given some empirical relationship. For the Moraine Dam glacial lake, they have given some empirical relationship. So using those empirical relationships, we have tried to work out what is the tentative volume of these glacial lakes. So this is the volume. Once we have analyzed all these things, then we have found that out of these 13 glacial lakes, these 3 glacial lakes, this we have found that potentially dangerous. One was Rafstreng, another was Thorthorby, and third was Luge. So here, if you see this this is Rafstreng glacial lake and this Thorthorby glacier, they are very close to each other. And here you can see the moraine also. And here the lake formation is taking place, number of small lake formation is taking place on the surface of this glacier. And over a period of time, they are going to convert into a big glacial lake. Actually, this type of glacial lake, or this Moraine Dam glacial lake Rafstreng, this must have also started like that only. And ultimately, all those small supraglacial lakes, they have combined together. And now it's you are looking like this one. Now, so based on that, what we have found, yes, 3 type of different combination could be possible. And we have considered different combination of the glacial lakes. So for Rafstreng glacial lake, our estimated volume was something around 13.6 million cubic meter. In the case of Rafstreng and Thorthorby glacial lakes, if they are combined together, then its volume is expected something around 53 billion cubic meter. And again, another Luge glacial lake, there we have found that its individual volume itself is something around 24 billion cubic meter. Now, we have used the breach parameter. Based on that, there are number of guidelines. So based on that, so these are some breach parameters what we have considered for the glacial lake outburst flood study. Only thing, in the case of normal dam, whatever the breach development time you are assuming, we have to take a smaller breach development time for the case of Moraine Dam breaching, because moraine dams are not the compacted dam. They are, that moraine material is quite porous one, and it is not well compacted. So here, if in the case of normal dam, your breach development time may be 2 hours or 3 hours for the development of full breach inside the dam. In the case of moraine dam, it may be of the order of 1 hour or 45 minutes. So considering that aspect, we have considered this breach development time. And now I will show you here. In this case, we have considered, because we were supposed to consider the attenuation phenomena also. And what we have seen, the majority of the glacial lake failure have occurred during the monsoon month also. And during the monsoon month, there may be flood in the river itself. If there is already flooding in the river, and at that time this glacial lake outburst phenomena is also taking place, then in that case your travel time or the flood wave speed will be, or flood wave will travel at a faster speed, and also its attenuation will be less. So we have considered this phenomena also, ki if without flood, without initial condition of flooding in the downstream valley, if this GLOF phenomena is occurring, then what would be the condition. And if some flood is already there, in that case, if this GLOF phenomena is occurring, then what will be the attenuation pattern of this flood wave? So these are the GLOF simulations for Rafstrange Lake. What you are seeing there, we have considered 60-meter top bridge width and 20-meter depth, and side slope we have considered 0.5 horizontal is to 1 vertical, and 1 hour we have considered the bridge development time. So what you can see here, this is the flood hydrograph just downstream of the glacial lake. Here you can see here this how this GLOF flood is its rising limb and then recession limb. So it will just come like a flash flood, and all of a sudden rise in the water level or the discharge will take place. But once this flood wave is passing, or this flood hydrograph is passing through the downstream valley, then you can see here significant amount of attenuation is taking place. Like this 4,000 cubic something like this year at 84 kilometer downstream, now its peak is 1800, and now you can see the base of flood hydrograph is also increasing, and up at 108 kilometer it is of the order of something around 450 cubic. So such type of attenuation take place in GLOF events. So these are the findings. What we have found, if at 84 kilometer this flood wave will reach something around 2.5 hours. In 108 kilometer it will take around 3 hours 50 minutes. So now another GLOF simulation what we have carried out for this is the Luge Glacial Lake. For that we have considered the top bridge width as 77 meter and breach depth at 25 meter, and here the lake volume was 24 mcm. So what we have found in this GLOF simulation, here at the lake location just downstream of the Moraine Dam, our peak was of the order of 5400 cubic, and here also you can see after 84 kilometer it is 2700 cubic, and after 108 kilometer it is something around 2100 cubic, and this is the travel time also. So these are the records. Here 2 hours 20 minutes, here 3 hours 40 minutes. Then we have considered combination of these two glacial lakes, this one and this one. If both are occurring together, then we have found here the peak will be of the order of 11,000 cubic, some 10,800, 11,000 cubic. And after 84 kilometer, this may be of the order of say 5,600, 5,700, and 108 kilometer near the project site, this may be of the order of 4,600 cubic or so. So based on that, these were the GLOF scenario. For this near the project site, if we are getting a peak of 4,600, and this Punakha, this is one of the famous phase. There we estimated it will be of the order of 5,600. But here at the glacial lake location, it may be 2U, something around 11,000 cubic. So based on the different GLOF scenario for this particular project, we recommended that apart from the design flood, for this project, probable maximum flood was the design flood. Then we told you have to consider 4,600 more discharge apart from the design flood while deciding the spillway capacity for that particular project. And this is the final GLOF hydrograph it was given. So based on the conclusion, now I will conclude here regarding GLOF phenomena. So this was particularly for a particular, just I wanted to say how it is analyzed and what criteria we are following for analysis of these glacial lakes or burst flood estimation. So there are hundreds of glacial lakes in different river basins, and monitoring these glacial lakes is almost impossible due to very difficult terrain. Most of the lakes are in the Tibet area. Glacial lake formation is a continuous process, and their bursting mechanism is of cyclic in nature. Hence, GLOF estimate is must for the project located in such basins. It is not like that. Yes, we are still monitoring. CWC is still monitoring of those glacial lakes. We are having the surface area more than 50 hectares. So for that, we are analyzing the time series of imageries, how much surface area change is taking place. But whether this GLOF event is going to happen, we cannot predict, because major reason we don't know when the avalanche will take place or when some rock will fall inside that. But yes, we have to be careful. Keep such type of GLOF phenomena is going to happen, so we can quickly estimate in 1 or 2 hours how much flood is expected in the downstream area. Though the glacial lake outburst flood peak may be very high magnitude at its source, its attenuation will be quite significant as the flood wave travels through the downstream valley. Like in the recent Rishiganga flood also, if you see, impact was very much there at Tapovan, but near when this flood wave it passed near the Kanprayag, its impact was almost gone. The same thing. So normally the time base of the peak segment of the GLOF hydrograph will be small due to relatively small storage capacity of the Moran Dam glacial lakes. Hence, attenuation will be significant as the flood wave passes through the downstream valley. The GLOF peak at any water resource project location will depend upon its riverine distance from its project. The very high sediment load associated with the lake outburst flood may bring the significant change in the river morphology up to few kilometers from its source, and also in the reservoir bed level for the runoff of the river hydroelectric projects. Sluice spillway with large gates should be provided for upcoming projects in order to pass the glacial lake outburst flood as well as sediment load associated with the GLOF safety. Thank you very much. This much I wanted to share with you. Thank you.
Thank you so much, Nityanand Raiji, for that very illuminating, very informative presentation. I think I personally feel I in last half an hour I've become more wiser on this very, and I must I feel very fortunate of witnessing these great presentations throughout this day today and even yesterday. This sort of demystification and decluttering of information you've done, you and your colleague experts on this entire concept of GLOF, Avalanche. One of the pie charts which you showed was that 75% of these impacts are due to snow avalanches, but yes, then there are 10% of other yes, issues also, and sometimes they come together.
Yes,
they come together. One triggers the other.
Yes,
and which happened in Uttarakhand in 2013, and something similar happened in recently on 7th February as well.
Right.
But I think there's a lot which needs to be done. I must congratulate you, Central Water Commission, and all the agencies which are working. Earlier in the afternoon, Director DGRE was also speaking, Dr. Lokesh Sinha, and they are on ground zero. So are you, ITBP, so many experts from IITs. I think what Varun and Uday also, their presentation was very inspiring before you. The incubation ecosystem of IIT was well demonstrated by them. One of these organizations which had developed something, one of the scientists in the university IIT developed something, and the IIT actually sort of encouraged them to open a startup, and have a sustainable model to their research. And today they have been in demand in cities like London. So if you are called in cities like London and New York, I would say, although it should not be a parameter, but then it is a very satisfying thing to know from a scientist perspective that your work has been recognized. And I think you have years of experience, Raisa, and I think we are very fortunate in a country like ours, which is so diverse, which has such, the vulnerability is almost, one of the most vulnerable states, I would say, as a country. When I say state, I mean as a country. We have a profile which is very vulnerable, but I think it's minds like you and experts like you which make us feel safe back in the mainland, sitting in our comfort of our homes and houses and offices, that we are looked after well from a preparedness perspective, because investigation is very important of what happened and learning from them. I think your presentation reflected that so very well. Thank you so much,
Thank you,
Nityanand Raiji, you and your entire team which has been involved in presenting this to us. Thank you on behalf of all the participants. Professor Chandan Ghosh, would you like to add something? I just gave a very general perspective, but it was such a overwhelming presentation. Thank you. Over to you, Dr. Ghosh. I think Dr. Ghosh might have filled out for something urgent, but then any which way, we have Mr. Himanshu Shekhar Mishra, editor from NDTV, with us now. Thank you so much, Himanshu ji, for joining us for this very important deliberation where we speak about resilient infrastructure. you have been a champion from not only a journalism perspective, but overall, I've been following you for quite some years now. And although I must admit and confess that my political opinions and my government-related opinions are very much influenced with your reporting. So thank you so much. And I'm really pleased that you could take out time to join us today. I hope, Himanshuji, we are audible. I hope you can hear us. I see he has unmuted himself, so we'll quickly do an audio check with him.
Okay, sir. So with your kind permission, I would leave now because I have some another meeting at 5:30.
Yes, please. Thank you so much. Thank you for sparing time, Rai sir. If there are any questions, we'll send it to you for your response later. Yes, thank you. Thank you so much. Thank you. Himanshuji, I will quickly check. Can we have a quick audio check with you, sir?
Yeah.
Yes, absolutely. Yes, we can see you. Brilliant. Namaskar, Himanshuji. Thank you so much for joining. I don't know if you heard me earlier, but I made a confession, a small confession, that most of my government-related views, government affairs-related views, are based on your reporting. So I'm a big fan of yours, and I've been following you for quite some number of years now. And so much so that your research work, which was presented in the World Management in Visakhapatnam as well as in Mumbai. So we were fortunate to be the industry partners as FICCI. So we've been closely tracking your presentations, which you've made on international forums also. I'm really pleased that you could take out time to be here. A lot of me and a lot of the participants also are really looking forward to your insights. In fact, we were also pleased that an experienced seasoned journalist we are so happy that you are also looking deeply into climate action, climate related issues, and your presentation today on a climate smart sustainable business model for industry. I think we have more people who are joining in now to actually hear you, and we are also live on YouTube where people are witnessing this entire online training program. Just to give you a brief, this is an joint initiative of NIDM and FICCI. FICCI perhaps is proud to be associated in the with NDMA and all the nodal, including CDRI, as the only private chamber or only business chamber to be working in the field of DRM. And we are very happy. For the past 15 years, we've taken that lead, and that's why we become an obvious choice for anyone who talks about disaster management and private sector involvement. FICCI comes into the fray, and NIDM has been a front runner, from an institute point of view of spreading capacity building initiatives in the country. Before I ask you, because I'm sure we're already running behind schedule, I would just give a brief introduction of Himanshu Shekharji to the audience. And meanwhile, I'll request Gaurav to put on his presentation on the screen, and we would run it for you, Himanshuji. So Himanshu Shekhar Mishra works as Senior Editor, Political and Current Affairs in New Delhi Television Limited. He covers Government of India and Parliament for NDTV. He was part of Prime Minister's official entourage to the UNGA annual session in New York in 2003, and also to Indo-Turkish Summit in Istanbul in the same year. He has covered Prime Minister's official visits to Pakistan in January 2004 and Afghanistan as well. He has also extensively reported and researched on issues related with climate-related disasters like floods, legal rights of disaster victims, threats posed by climate change to the sustainability of development processes and industry, the potential impact of COVID-19 pandemic on sustainable development goals, a very, very important subject that the world is right now reading about, and Sendai Framework for Disaster Risk Reduction 2015 to 2030 targets as well. He has been an author to various known research papers, especially unprecedented floods in Jammu Kashmir in September 2014, and was selected for presentation at the 3rd United Nations World Congress on DRR in Sendai, Japan in March 2015 as well. His research paper on urban flooding and threats to sustainable development is also a big hit in a popular research paper, which is published in the edited volume titled Disaster Risk Management in Agriculture by the Business Expert Press in April 2019 in New York. He holds a Master of Philosophy and MPhil degree from Center for West Asian Studies, School of International Studies, JNU. Prior to that, he did his postgrad in political science from Center for Political Science Studies, JNU, and graduation in English honors from Delhi University. I don't need to say anything more, sir. We are just looking forward to hear from you, your thoughts on a climate smart sustainable business model study, for industry. To you, Himanshu.
It's a privilege, sir, to hear you. Thank you very much for this very important opportunity and also for selecting and creating this platform where such meaningful interactions and interface between different stakeholders has become possible. And this is the kind of interaction interface India needs more and more if we have to not only create disaster resilient infrastructure, that right ecosystem in the country to fight disasters. As you know that we are now living in an age where climate change is a reality, and research data at several levels has shown that climate change is now inducing more and more disasters, which is not only a threat to human life, but also to the industry as well. I'll come to the main slide a little later, but just to give you an insight that if you just look at 3 disasters in India, the 3 big ones in the last 6 years. Jammu and Kashmir floods, which I covered as a reporter for NDTV in September 2014, was the most expensive disaster of 2014 in terms of the economic losses it cost, $16 billion. Chennai, which followed 14 months later in December 2015, initial estimate was $3 billion. Later on, it was subsequently increased. And then Kerala floods, 2018, which cost 40,000 crores, that is around $5.7 billion. So if you just look at these 3 flood incidents in India in the last 6 years, the losses come to around $24 billion. And that is the quantum of loss that is being now caused. And if you add up all the disaster incidents that have happened since September 2014, you will have the larger picture that I'm trying to paint before you. And that is the reason why we need to focus and work more and more very seriously on a disaster resilient infrastructure systems in the country. And as a very important representative of the industry, as a reporter, sir, I can tell you I've been covering FICCI for 15 years. I have interviewed several FICCI members several times on a budget day, on an off day as well. And I have been very thankful, in fact, for a lot of research material that comes from FICCI, which we use in media also. And I'm sure that that is also helps in creating that right discourse. And I'm sure that this kind of interface is also disseminated at the larger level, at the international level, so that ecosystem is created not only in India, but considering the international borders, magnitude of the disasters in recent years, it's very important that industry, not only in India, but at the global level needs to come together. And that process, of course, has also started. And I will come to that later. Sir, I wish to start my presentation with those horrifying images we have seen, which shocked not only India, but the world at large. And of course, this is an image which is difficult still to imagine something of this kind can happen. And of course, that is why the unprecedented scale of the disaster incidents that are being reported is one of the reasons why we need to work more and more on the subject that we're discussing today. Now, the next slide, of course, is also shows, and there is a ring we made. This is an NDTV image issued by Indian Air Force. And this is what was left of the hydropower project after the devastating disaster incident that happened. Next image is also a different image of the same tragedy after the floodwaters have receded. And you can just see, and that makes you very clear in terms of the quantum and the scale of the devastation that was caused by the disaster incident. And the fact that 12 days after the Jammu disaster incident, there are 140 people who are still missing. And that gives you a broad idea of the scale of the challenge that we are discussing. The disaster comes, it devastates and demolishes everything that comes on its way. And 12 days later, there are 140 professionals who are working in the power project are still missing. We have not been able to search them. Only 31 recovered bodies have been identified. This is another humanitarian tragedy in the sense that one can only imagine what could be going on in the families of these people who are missing. This is, of course, the economic losses in terms of quantum. I would say not a very big sum, 1,500 crores, but this is, we are talking about just one project that has happened. But of course, it affects the scheduled commissioning of this project, which was earlier scheduled, as Power Minister told us, R.K. Singh, when he visited the site, that it was scheduled in 2023. But the considering of the images that we now see, of course, this is bound to get delayed. This, of course, highlights once again and brings us to the main issue that we're discussing today on why India and the world needs to create more and more disaster resilient infrastructure so that we can keep ourselves safe and we can keep our money, our capital, our power projects, our infrastructure projects safe. Now, two questions have emerged from this disaster, and this has been a part of a national debate which has been going on for the last several years. One, of course, is the project design. How do we design projects, especially in disaster-sensitive zones? This is an issue which is cropped up in the wake of this disaster. Are we designing our infrastructure projects in a way where we weave a disaster risk reduction vision in our projects? Are we doing these kind of assessment exercises, considering the scale of this tragedy, for example, a very important lesson in the sense that, of course, considering the scale of the tragedy, one can obviously argue that people and the professionals and the managers working on the site perhaps had never envisaged that such a disaster incident can ever happen. But that is exactly the challenge that we have to fight together. Now, the second issue that emerges is that the climate change is inducing more and more abnormal changes in the global weather patterns, leading to a worrying rise in both the frequency and the scale of disasters. And these are two issues, broad issues that industry, I think, needs to work on almost, I would say, at a war scale, because in the coming years, as more and more money and the fund is being invested and lots of risk is being taken by the industry to create these industrial projects, we need to work seriously on addressing the challenge that climate change is posing. And that brings me to a very important research which was conducted by the United Nations Disaster Risk Reduction, which is the nodal agency, UNDRR as it is called, of the UN. And they found that between 1976 and 1995, total number of climate-related disaster events like floods, storms, heat waves, more than doubled from 3,017 events recorded between 1976 to 1995 to 6,392 disaster events recorded during the subsequent 20-year period from 1996 to 2015. That essentially means that the threat has doubled. The challenge, consequently, has also doubled before us. And Emergency Events Database, which is a very respected portal, EMDAT as it is called in short, recorded an average of 341 climate-related disasters per annum since 2000, which is 44% above the 1994 to 2000 average and more than twice the level in 1980 to 1989. So this is the second research by a different institution, which has also substantiated the outcomes of the research globally carried out by the United Nations Disaster Risk Reduction Agency. Now, what does it mean for the industry at the global level and in India? ISCAP, as it is popularly known, said in its latest report in 2019, to make infrastructure resilient to disasters and climate change would require an additional investment of $434 billion per year in Asia-Pacific region alone. So if you just look at the larger picture, America, for example, is the worst disaster-affected country in the world. Japan, second largest, most affected country in the world. If you look at the losses the disasters have caused, including some of the most developed countries in the world, including those in the Europe, then the numbers would be trillions of dollars of funds would be required to create this kind of disaster resilient infrastructure. And that shows you the quantum of the challenge that disasters are posing before us. That brings me to the main framework, the global framework that exists, to which India is also a signatory, and it very well codifies the roles, the responsibilities, the challenges, and the priorities and objectives of not only the government of India, but also of the industry. We'll come to that later. There are two SDGs which are important for the industry, important for the government, important for all stakeholders. One is sustainable goal number 9, which says build resilient infrastructure and promote inclusive and sustainable industrialization. Now, this is a goal, this is a target that the global community had fixed for itself in September 2015. Now, we are more than 5 years ahead of these goals, but United Nations latest research shows that countries are not moving as they should optimally to attain the goal number 9, which codifies the roles and responsibilities of the industry. Very specifically, I'll come to that later. Goal number 13 deals with climate change. Urgent action is required to combat climate change, and it codifies a disaster risk reduction agenda for India and the global community as well. And the most important thing is that even during lockdown, it's important to understand that United Nations that climate change is running much ahead of us in terms of our responses to meet the challenge that it poses. And even during COVID-19, when most of the world for many months was under lockdown, industrial production was stopped, even then, there was only an expected downfall in the carbon emissions, greenhouse gas emissions, is just around 6% drop is expected in 2020. That shows you the quantum of the challenge that is still short of the 7.6% required annual reduction to limit global warming to 1.5 degrees Celsius, which was the target fixed in the Paris Climate Conference. This is the data that every industry leader must study. Even during COVID-19, when we know that India, of course, had one of the most stringent lockdown imposed and the industrial production came to almost a halt, still the required greenhouse gas emissions, which the global community had set for itself in terms of its nationally determined contributions, India, of course, was also a signatory. We were still falling short of what we should be doing. And that gives you the larger challenge that lies before us in terms of fighting climate change. Of course, Paris Climate Agreement, I need not repeat it, but of course, it does say the urgent need to limit the global average increase in temperature to below 2 degrees Celsius above pre-industrial levels by reducing emissions to 40 gigatons or to 1.5 degrees Celsius above pre-industrial levels. These are the targets that had been set up through consensus by the global community. India is a signatory, and these are targets which are targets not only for India, but for every industry in the country. Now, these UNFCCC protocols have been ratified by 189 parties, but consequently, India, of course, has done well, but many developed countries have not done or are very far away from the target that they had set. And that brings me to the idea that why a climate smart green business model has become imperative for the industry to follow, and significant changes in global climate are triggering abnormal changes, and that makes it imperative for the industry to take the first steps. Now, NASA data, of course, is something that we've been reading about, but these are terrifying figures. Level of carbon dioxide in the air is highest ever in 650,000 years. 17 of the 18 warmest years in the last 136 years have been recorded after 2001, with 2016 being the warmest ever. The increase in global temperature since 1880 is 1.8 degrees Fahrenheit. And that's the big challenge. The average increase in global sea level, we've been reading about it, that glaciers are melting much faster, leading to a rise of sea level, which in turn has its own repercussions, especially in the coastal areas. As you know, India has 7,516 kilometer long coastal line, across which several industries are located. And as the sea levels rise and climate change becomes more and more reality, the threats that these incidents, the developments in our weather is only increasing. Now, global sea level has risen by an average of 3.1 millimeters per year. This is NASA data of 2018 since 1993. It is becoming a kind of a routine affair. Now, the UNCTAD Trade and Development report very categorically fixes the responsibilities of the stakeholders when it says the threat of global warming requires immediate action to reduce greenhouse gas emissions and stabilize the Earth's climate. Recent studies by Intergovernmental Panel on Climate Change, IPCC, and the United States Global Change Research Program have made it clear that if we fail to change course, we are only a few decades away from disastrous climate-driven losses. And we are already, I think, in that phase with the kind of disaster. Now, I will just quickly go through 3 disaster incidents that I had covered as a reporter. Kashmir floods, I covered it from the ground, and the other 2 flood incidents I had covered from a distance. Kashmir floods. Now, I will request you to show the first image of the Srinagar city. This was shot from an Indian Air Force aircraft, and that gives you the idea of the quantum of the damage that floods did. Now, you just look at this image. This an aerial image of Srinagar city a few hours after the flood waters had entered the city. And as far as you can see in this image, everything was destroyed. There was no power in this entire area. There was no water supply possible. Roads have disappeared, as you can see in this image, and this had actually devastating impact. The next image, of course, will give you a much bigger picture of the kind of devastation that Srinagar floods had caused. And in this is also those industrial units. There are shops, there are industrial parks which were completely destroyed in these floods. And the Annual Disaster Statistical Review 2014, a very respected research document published every year, which studies the losses that disasters cause. It said the costliest natural disaster in 2014 was the flood in Jammu and Kashmir region, which cost India $16 billion. Now, Jammu Kashmir is a very small state, as you all know, and $16 billion, if that is the quantum of the loss that these floods caused, I think for many years, Jammu Kashmir government did not recover. In fact, the earlier estimate that was submitted to the Ministry of Home Affairs said that the losses were in the excess of 1 lakh crores. Now, these are the images that we shot as reporters on the ground. As you can see that these shops are flooded and they remained flooded for many weeks, at least for 2 weeks. And that in turn ensured that all the goods kept inside these shops were completely destroyed. Now, this is another image. As you can see, people just trying to desperately save themselves. They have carried whatever was left. And as in this image also, you can see those shops which are completely flooded and shopkeepers lost everything. Now, another image will give you a little aerial picture of the devastation that it caused on the ground. Now, 4,207 power substations submerged. That essentially meant that electricity supply was completely cut off. Horticulture sector, a major sector in Jammu Kashmir, a major contribution it makes to the Jammu Kashmir economy. 1,568 crore was the loss. Crop loss, again, more than 5,600 crores and 11,000 kilometers of cables damaged. And imagine how much time and how much energy and how much resources and how much of finances would be required to actually reconstruct 11,000 kilometers of cables which were damaged. Now, ASSOCHAM also had estimates of the losses that it caused. And the most important was the speech that the finance minister of Jammu and Kashmir made in the assembly on 22nd March. And he said that the total income of the state declined by 1.5% in 2014-15 to a less than 88,000 crores. And the per capita income declined. Now, this kind of per capita income had declined last time was during the Spanish flu of 1918, which killed more than 12 to 13 million Indians more than 100 years ago. And at that time also the census report of 1921 says that the per capita income in India, in rural India, had actually increased because of the large number of deaths. And that is the kind of impact that Jammu Kashmir floods caused in a state which is very small. And because the industry completely came to a standstill, the revenue collection fell incredibly. And this led to a decline of the state's income by 1.5%, which is a huge loss. Now, the second big disaster that India faced was 14 months later when the Chennai metropolitan area went underwater. And this is another aerial image of the Chennai metropolitan area. And I will request the IT engineer to show the next image of the airport, which was completely flooded. And that became the image, the defining image of the Chennai floods. And as you can see, the airport became dysfunctional and the losses that it caused to the airport infrastructure in Chennai was very, very huge. And ASSOCHAM estimated that the initial estimates in the first few weeks was 15,000 crore rupee that was lost. And I have put images and the losses that were studied to the industry. I will just read few lines. Hyundai, Ford, BMW, Nissan, TVS, Renault, Nissan, and Ashok Leyland were forced to shut production. Now, this Chennai metropolitan area is very, very important and significant industrial area where large number of car manufacturers had their production units. They had to be shut down production for many, many weeks. Ashok Leyland plant at Ennore, 2 plants of Hyundai Motor India Limited facility in Sri Perumbudur, producing 680,000 units. Ford India's facility with an annual capacity of 3.4 lakh engines and 2 lakh vehicles, and a BMW plant were among those which were impacted. With losses in sales of nearly 15,000 units, TVS Motor Company was another firm that took a massive hit. That's the cost that the automobile industry faced during this disaster. And during that disaster, a debate became in India, and I've been reading documents on this, which is called the catastrophe insurance. Now, if you read the US government's literature, catastrophe insurance is very prominently discussed. But in India, this is a subject which did crop up after the Chennai floods, after the Kashmir and the Chennai floods. And a group of non-life insurance companies presented a concept paper to NDMA. But no progress could be achieved because questions related to who will fund this initiative has not yet been addressed. That is a challenge which remains before India. And that is why most of the losses that disasters are causing to the industry, there is no system of insurance that seems to be working on the ground. Now, no broader consensus on the question and the concept of insurance and reinsurance. Reinsurers are not comfortable taking a big exposure in the disaster-prone zones, and that is a challenge which remains today. Now, the third disaster happened in 2018. Kerala floods, as you know, one of the most devastating flood incidents in India's recent history, and the worst monsoon disaster in the state since 1924. Imagine, and I'll go take you back to the Kashmir floods. The Kashmir flood in September 2014 is considered the worst flood since 1902. And the Kerala flood in 2018 is the worst flood in Kerala since 1924. That gives you the quantum of the challenge that is before us. And if you look at the quantum of the rainfall between 1st August and 19th August 2018, 164% above rainfall. Now, are we designing our industrial projects where such kind of unprecedented rainfalls are expected? I think the answer is no. It affected 5 million people, a large number of people were displaced and killed. Total crop area, I'll quickly go through this. Infrastructure losses, it damaged 365 kilometers of district roads, 2,590 kilometers of panchayat roads, and 106 kilometers of state highways. And the State Industries Minister, E.P. Jayarajan, said that Kerala had suffered a loss of 40,000 crores. That is, comes to the present, at the present term, around 5.7 is the larger $1 billion losses that were estimated. This Dr. S. Sajid Kumar, Chairman, Kerala Chapter of the Confederation of Indian Industry, said that our estimates in capital investments, machinery, were to the tune of 20,000 crores, another 10,000 crore and 20,000 crore were indirect losses. So that is the quantum that 40,000 crore, imagine a state like Kerala losing 40,000 crores. I'm sure that they have still not recovered from that. And so if you just add up these 3 disaster incidents, this is one big picture that comes up. And I'm very surprised that no data exists on how much is the economic loss that industry has actually faced, just say after Kashmir floods, for example. And I've been trying to research, trying to get the data. Individual assessments exist of different disasters by the industry, but there's no mechanism that exists as to at the national level as to what is the quantum of the loss that disasters are causing. And this is a gap, sir, that I want you to actually fill up. You have to put in place a mechanism which regularly updates media, regularly updates the stakeholders in terms of the economic losses that industry incurs during these disaster incidents. So there's 3 disaster incidents: Jammu and Kashmir, $16 billion; Chennai floods, $3 billion. This is a rough estimate. Kerala floods, $5.7 billion. If you just add these 3 flood incidents alone, the total losses, economic losses, comes to $24.7 billion. Now imagine in a country where the concepts of insurance and reinsurance is not very well popularized, the quantum of losses, once the money is lost forever. Now, the assessment, Met Department DG conducted a study of Kerala floods, and he was the first official to say on, I interviewed him. He said that Kerala flood was an outcome of climate change. This is an interview which was in November 2018. And he did say Kerala flood were an outcome of the impact of climate change itself. Country has witnessed the evidence of significant changes in extreme weather events, and the extreme rainfall in Kerala happened because of these changes in India's climate. In terms of rainfall, it was exceptionally high. And that is where the idea of creating disaster resilient infrastructure becomes very, very prominent, where we need to devise project designs and plans, keeping in mind weaving a disaster risk reduction vision in them. Now, India ranks 5th in the global list of most vulnerable nations. This is the Global Climate Risk Index 2020 report. This is the latest report, and India is the 5th in the global list of most vulnerable nations to climate change. This is, of course, shows you the quantum of the challenge that we face. And of course, government has admitted in Parliament that climate change is beginning to have a significant impact on the frequency and intensity of weather-related events. And in fact, Dr. Harshvardhan, who is also the Science and Technology Minister, said in Parliament on March 6, 2020, where before the lockdown was imposed, the country has witnessed increase in extreme weather events like extremely heavy rainfall leading to floods, severe heat waves, cyclones, etc. And the study shows increase in frequency of severe cyclones over the Arabian Sea in recent years as well. And rise in frequency of cyclones, 2017, 3 cyclones where India had to suffer. 2018, number increased to 7. In 2019, it increased to 8. So this is very, very worrying news for India's coastal region, which is of course 7,516 kilometers long. Now, the occurrence of 5 cyclones over Arabian Sea in 2019 against the normal of 1 per year equals the previous record of 1902 for the highest annual cycling frequency over the Arabian Sea. Now, the sea level is behaving abnormally, making it difficult and challenging for our Met scientists also to correctly predict the movement of the cyclones, and that in turn has ramifications of managing the impact when the landfall actually happens. Now, sustainable development goals. India's share in total global emissions, of course, is not very high in terms of the most developed countries like US and UK, but it's still at 6.8%. Important thing is that India has done well recently, and we have been told, Environment Minister Prakash Javadekar did say that India is at the moment contributing 6.8% of global emissions, and the per capita emissions is 1.9 tons. But importantly, he said that India has achieved 21% of its targets of reducing emission intensity of GDP by 33 to 35% by 2030. Now, I think India is one of the very few countries which actually has managed to achieve the target it had set for itself. And Environment Minister said, while talking on the 5 years of Paris Agreement, is talking about the nationally determined contributions India had made, where both government and industry had very critical role to play. It was decided that every year the world will set aside $100 billion for developing nations to combat climate change. Now, India is reminding the developed world that they're not keeping the commitment they made at the Paris Climate Conference. But Minister said very categorically, it was decided that every year the world will set aside $100 billion for developing nations to combat climate change. But now more than $1 trillion is pending. Technology transfer is not happening. If climate change is a disaster, then there should be no profit in technology transfer. Now, India has reminded to the global powers that they are far, far behind the targets that they had set for themselves. Now, the next step, what has the industry done? Now, these are the critical points. Now, I'm coming to the implementation part of the SDGs. Coal Ministry has made it mandatory for all new coal-based generating stations to use supercritical technology to reduce carbon footprints in the coal industry. Old coal-based power stations are being gradually modernized. Stringent emission standards for thermal power plants are being put in place to reduce emissions on the ground. Indian steel companies have initiated steps to adopt state-of-the-art clean and green technologies. Government has also facilitated adoption of energy efficient technologies in steel re-rolling mills. Telecom Regulatory Authority of India, TRAI, has recommended specific targets for carbon emission reduction in the telecommunications sector. 30% by 2019-2020 was the target, and taking base year as 2011-2012, and 40% by the year 2022-23. And this is where industry has a very, very important role. A process of incentivizing the use of renewable energy technology in the telecom sector is also being initiated. National Thermal Power Corporation Limited, the biggest power producer in India, has set an ambitious target of being a 130 gigawatt company with a diversified fuel mix by 2032, with 30% to be sourced from non-fossil fuel-based resources. This is very, very critical. Even Indian Railway has also started using renewable energy sources to run its operations. Second major nationally determined contribution that India made was with regard to achieving 40% cumulative electric power installed capacity from non-fossil fuel-based energy resources by 2030. Now, this is again very, very critical for the industry to work on. Government has set up a national solar mission, has fixed a target of installing 175 gigawatt of renewable energy capacity by 2022 for increasing the share of carbon-free energy in the larger energy mix. It includes developing 100 gigawatt from solar, 60 gigawatt from wind, 10 gigawatt from biopower, and 5 gigawatt from small hydropower sources. Now, these are data I've got from Parliament of India. Wind energy is an important component of the renewable energy growth in India, and India is the 5th largest wind power producer. We see that Government of India and Cabinet routinely approving big projects in this regard to achieve the next goal, which is the target of 60 gigawatt of wind power installed capacity by 2022. Now, focus on developing solar power infrastructure. Prime Minister Narendra Modi has himself pushed this idea fast during his term. The solar power installed capacity has increased from just 3.7 megawatt in 2005 to about 4,060 megawatt in 2015, with a CAGR of more than 100% over the decade. The larger target is to increase the capacity to 100 gigawatt by 2022. That's the target India has. Now, India has also committed to create an additional carbon sink of 2.5 to 3 billion tons of CO2 equivalent to additional forest and tree cover by 2030. And we are actually moving in the right direction as far as this target is concerned. And then that brings me to the central idea of my presentation, which is the challenges and policy bottlenecks that industry and the government faces. Underdevelopment, institutional failure, and bad governance aggravates the damages disasters cause to human life and economy. Absence of sustainable development practices intensifies the risk posed by disasters. And we have several lessons to fall back on to understand what this idea actually means. Indian industry needs to create a sustainable development framework and invest more in disaster governance research, especially on capacity building. And they need to develop an integrated approach towards disaster management and development planning. And it will be necessary to improve the disaster governance measures and strengthen the mitigation and risk reduction capabilities of the stakeholders. India has to further align its disaster risk reduction and climate mitigation strategies with Sustainable Development Goal number 9 and 13, and also the Sendai framework for disaster risk reduction targets. India needs US $2.5 trillion to meet the SDG targets. And this is the target. This is the amount that was mentioned in Parliament of India by a senior minister of the government, Mahesh Sharma. And in 2018, this is one of the rare instances where Government of India has actually put important data in terms of how much money is required to meet these targets. As per India's nationally determined contribution submitted to the United Nations Framework Convention on Climate Change in 2015, at least US $2.5 trillion would be required to meet the 2030 targets. The question and the challenge that government, industry, and the stakeholders face today is from where these $2.5 trillion are going to come, which is needed by 2030 to address all the challenges and bottlenecks that we are facing today. How will that be mobilized is a big question mark. Now, United Nations Environment Programme has said to contain the rising global average temperature below 2 degrees centigrade, which is the target above pre-industrial levels, up to US $1 trillion. Additional investments would be needed annually up to 2030. And this is the point I mentioned earlier. This is where the global industry needs to join hands together to mobilize funds at this larger scale, because we see that countries have lined up trillions of dollars of investments in the infrastructure sector. And to protect this investment, critical investment, which is required for human development and creating jobs, they need to spend heavily on creating disaster resilient infrastructure. NDMA has estimated that globally annual investment in transportation, power, water, and telecom sectors, these are critical sectors in disaster management terminology. Power alone is estimated to reach $53 trillion by 2030. That is almost 2.5% of world's GDP. That's the degree and the quantum of investment we are moving into, and that is why we need a climate smart approach to address these challenges. Public and private sector enterprises and organizations need to adopt a flexible and innovative approach. Organizations will have to restructure project designs and management practices, incorporate a disaster risk reduction vision in their business models. They must invest in disaster risk reduction measures to safeguard their long-term investments and capital assets. And the last point I wanted to make, this is one of the image of the presentation I had made, and I had the privilege to be present in Sendai on the day when the Sendai framework was globally, through a consensus, approved and made public. And it said very categorically that this was one of the first global attempt actually to link disaster risk reduction with sustainable development initiatives. And India, being a signatory, is bound by these laws. Now, what does Sendai framework say? It categorically makes it mandatory for small and big business enterprises to integrate disaster risk reduction practices in their management practices and enhance the investments in disaster risk reduction strategies. To incorporate a disaster risk reduction vision in India's economic development agenda, it would be important to strengthen the risk coverage mechanism by promoting disaster risk insurance culture among both poor and rich, small and medium enterprises, and also multinational corporations. And it categorically says in Section 5, I will just read the small part, business professional associations should integrate disaster risk management, including business continuity, into business models and practices through disaster risk informed investments, especially in micro, small, and medium-sized enterprises, engage in awareness raising and training for their employees and customers, engage in and support research and innovation, as well as technological development for disaster risk management, share and disseminate knowledge, practices, and non-sensitive data, and actively participate as appropriate and under the guidance of public sector in the development of normative frameworks and technical standards that incorporate disaster risk management. Now, these are the targets: reducing emissions intensity of India's GDP, usage of low carbon, low emission, cleaner technologies to create cleaner and climate smart growth. And that is the central idea that I wanted to present, sir. We need to think also about catastrophe insurance. These are ideas which are becoming more critical and important. And under the corporate social responsibility also, I think corporates and business enterprises, they need to focus more and more on creating disaster mitigation and sustainable business practices. These are important for saving lives, saving jobs, saving capital, saving investments. And that is where industry has to develop risk assessment methodologies, risk metrics and indicators of sustainability also for different infrastructure classes to constantly monitor how far they are progressing in this direction, financing of disaster resilient infrastructure, including risk transfer mechanisms, and a viable reconstruction and recovery plan, which is becoming very critical in the wake of the Tapovan disaster. So that's the central idea, sir, that I wanted to present. And you're free to ask questions here. Thank you.
Thank you so very much, Himanshu Shekharji, for that very, I would say, informative, thought-provoking, and I think a very intriguing presentation. I think you've touched upon some very, very critical aspects. I think, you know, and I didn't even realize it, you know, we wish it continued, because you were talking of, you were touching such important pain points. You talked about resilient infrastructure in such detail, because that is the key. I will give you a small example just to reinstate what you were saying. In 1999, when super cyclone hit India in Odisha, we lost over 10,000 lives. Cyclone Fani, 89, Cyclone Amphan, 118 official deaths. We as a country have come a long way in sort of saving lives from from humanitarian point of view. Yes, there is a lot to be done, and with NDRF being at its peak right now, with working on international standards, thanks to INSARAG's upcoming certification, now it will be an international force for rescue. I think what you also rightly said, in protecting our infrastructure is the key, because for growth of our economy or any country's economy, I think the more we invest on saving, in a layman's language, and technically now resilience word has become a layman word as well now, hopefully it does faster. Resilient infrastructure building is very important, because in 1999 compared to now in Amphan, and Amphan even only in the power sector, we lost almost 8,000 crores in Odisha. I'm sure this could have been the total figure back in 1999 on infrastructure, but right in 2020, in 2019, it was 8,000 crores only on power infrastructure. So there is a lot which we need to do, because we can't afford to develop on one hand, and on one hand being dragged back number of years because of these frequent pre-warned disasters, I would say. We have technologies, innovations which give us enough pre-warning, but I'm overwhelmed with the data which you shared. And honestly, although I follow you very much on your reporting, but some aspects about you, the sort of insights you have, the sort of thoughts you provoked through your presentation, through your very personal research also, I think it was very pleasing and very encouraging, I'm sure, to a lot of our participants who on the chat window have been personally sending me messages that they did not expect a media journalist to have such knowledge from a technical perspective. And for industry, I think you have also set the path very right. These are the issues which the industry wants to focus on, and with the current the government currently, with their focus on resilience, infrastructure resilience, especially their initiative CDRI, you are very well aware of that, the Coalition for Disaster Resilient Infrastructure, which is an initiative of India, and many countries, many development agencies are also joining hands. I'm sure we are up for a better future, more resilient future, and I think your path, we've noted them down, and we are very fortunate that in today's COVID or post-COVID era, we are recording almost everything which is coming our way. It is live on YouTube. People can witness that. With my humble experience in disaster management since 2015, where I worked with NDMA, I think, and previously to that, in West Midlands Ambulance Service in England, I think what I experienced in England from 2003 to 2006, I see it happening now. For the past 6, 7, 8 years, I would say, or 10 years. But the first biggest move was NDMA being formed. Yes. So, and I'm sure with the great minds working with people like Dr. Chandan Ghosh, who is the head for disaster, so resilient infrastructure in NIDM. I think he has been brought back from IIT Jammu to focus on this, because people like him are required in the mainstream, at the national level. And I can go on and on, but I would now request Dr. Chandan Ghosh to say a few words. And thank you again, Himanshuji, for your brilliant presentation.
Thank you, Chandan sir, for this idea. I had the privilege to discuss this with you briefly yesterday evening. And once you approved it, I could just collate facts, and I took it forward. Yeah, thank you very much, sir, for guiding me for this presentation.
No words are enough. Rubab already talked about, and no words are enough to say you that your temperament as well as tenacity and experience that that you are going from a class of people or class of organization that we often do, that you belong to, but you are par excellence that you have taken all these national and international issues and highlighting that what are especially the 3 examples that you have taken, and very specific, targetful that information that which you have showed through your presentation to our participants and world body. It is, I think, no words is enough to put in the line of appreciation for you, even though we are of course in a grip that whatever has happened 12 days before, of course, whatever still work is going on in Tapoban and the rescue work and all those 140 plus body which are to be traced. And even in this COVID situation also, which is again coming back, but sharing over this information to a larger participant, highlighting especially the Indian context to the UN declaration, that which you have very categorically that you have shown, and taking that what Parliament has decided and what are the actions going on. And in fact, in the morning, just before you came in, I shared that NTPC person, they are now looking for to check that auditing of the disaster that happened and remaining that what sectors that say that there should be infrastructure auditing. Please help us to identify those experts. We want to do it immediately, so that taking this lesson forward, which is a very quick reaction, we say that we want immediately. Then we had discussion that yes, we have number of experts, but we can meet now and we can see that it will not take even a week time to get a preliminary idea about that through a simulation, through software and simulation, and how much of silt is going to be carried. Like here 50-60 feet of silt is there at the Tapoban, which you have shown in your beginning slides, and which are all available even in the media also. So there are capability are looming large across the globe, both Indian scientists and scientists working in a platform, that they have got this capability to say that how much silt will be carried, where from it is being carried, and how it can be diverted. All these things can be simulated. In fact, I want to just show a 2 minutes video here, that which I have shown at least 100 times in the last 10 years. This one I want to show just to say that, to add to a flavor to something, I suppose, is that what exactly happens and what we could not do even in the last 10 years, but things are available. Can you share my screen, Akhil? Just it is a 2 minutes video.
Yeah.
2 minutes video. I want to show that. Okay, screen is there. Just I want to show that what really cloud, how landslide lakes are formed. It is a synthetic information which you can see that yeah, I think it is shared. Okay. Can you see this video?
Yeah.
Okay. So this is a just Google Earth was born in 2002 or 3. So this was made in Japan. In fact, that time it is a situation which you can see the sound, that whatever terrain that we have shared, and the way that whatever things that has happened even in the current cases, and several such lakes that which are waiting to go dry or waiting for flood, waiting to get it. So you can see that how artificially that these scenarios are created. So this is here artificially earthquake is made, and then landslide occurred, and then glacial water or rainwater got accumulated. So these are the kind of scenario that through which we can take some measures. And these are all more than 15, 16 years before this video was created. But you see that post box, how they keep it so that it doesn't get dropped or water, some higher soil. So there are a lot of things that they have simulated over here, that what are the measures to be taken. So just only I say that okay.
I think this clearly reflects, what even Himanshu was also mentioning. When it comes to infrastructure, power, telecom, airports, highways, everything, the deluge would affect everything. And I think this is an opportunity, I would say, also for our country to take lead, because the world is looking at us, from intellectual point of view, technology point of view. I think it is the time for us to raise that bar. What the vision of which was declared announced by our Prime Minister, Honorable Prime Minister Shri Narendra Modi ji in UN's Climate Summit, where CDRI was formed, and Dr. P.K. Mishra has been instrumental in putting that all together. And today we have an active organization working on ground, some great minds working behind and focusing on power, telecom, airports, critical infrastructure. And I think this is how we start. And we set a path, not only as a country to go forward alone, but taking everyone together, developing and developed nations. I think this is a great opportunity for us to make that impact, positive impact. But I would like to again thank you, Himanshu ji. I know you are hard pressed for time. You have so many other commitments. I'm looking forward to your next reporting. And so please, thank you so much for sparing time. It means a lot to us, and we look forward to having more such interactions and deliberations on the same subject of how industry should be more resilient,
towards disasters, and we would keep inviting you, having you in our discussions on the table, so that we can have your perspective and your expertise, which can benefit all of us. Thank you so much again, Himanshu, for your time, for your effort. Thank you.
Thank you, sir, for this opportunity, because you have created a platform that such interaction or interface is possible, and I think you need to. And Chandran sir, of course, knows it better. You need to create more and more such platforms, especially the state level, where the disasters actually have to be fought on the ground. And it's a great learning experience for professionals like me, that when I sit with people, when I study more, when professors like Chandan Ghosh ask me to make presentation, I start studying about it, and that's how I learn also. Because otherwise it's very important. Teachers are very important in life.
Absolutely. I think we are all very privileged.
Thank you, sir. Sir, thank you very much for this opportunity, and thank you, sir, for this great interactive experience. And the fact is very encouraging for me, and I just hope that more professionals also start doing research. That's where the volume of new research new knowledge can be created, and that in turn strengthens our hand when it comes to fighting and combating.
Absolutely. Thank you so much. Thank you.
On a personal front, you see, he was busy 2 to 5 in an academy giving lecture. At 5, he made it sure that he will be made available here. And so he's a great. Last 2 days, he was busy morning to evening. He could not respond to even telephone call. Last night only he called me back that yes, I am on the anvil. So he sent his everything. So, so Himanshuji, safe home journey tomorrow.
Thank you.
Thank you so much. Thank you so much, Himanshuji. Have a great evening ahead. Thank you. We'll be in touch. We'll be in touch. Thank you. Thank you. So I think, Dr. Ghosh, we've had a very interesting day of deliberation and discussions. I think we couldn't have imagined for more. I think the participants are still, almost 200 numbers still with us. And there's some on YouTube as well. So we won't keep them for long. I know they need energy for tomorrow also, being a Saturday. We start on the same time at 2:30. Please make sure that everyone signs in using the same email ID, because we take attendance for all 3 days. We'll make sure you get a certificate. You qualify to be issued a certificate. We start at 2:30. We've got some speakers, very eminent speakers from IIT Roorkee, from Physical Research Laboratory, Anil Shuklaji, who's been very kind and who's been with us all throughout. Chairman Aqua Foundation, Dr. Sanjay Rana, and Dr. Surya Prakash, Professor and Head, and a dear colleague of Dr. Chandan Ghosh, who will be speaking from the Department of Geometeorological Risk Management Division. He will be sharing his thoughts and his insights. So I think we're getting a lot of compliments showering, these participants showering their compliments. Great session, good speech, and they said that it couldn't have been a better platform to spend their 2 days, and they're looking forward for the 3rd day as well. So I think we will, we will sign off from for today, and until we meet next tomorrow at 2:30 again. A very good evening, and have a great day ahead.
Thank you.
Thank you.
Thank you, everyone.
Right. Bye-bye. Right. Bye. Thank you, Gaurav. Thank you for your support, brother. Thank you.
Thank you, Varun.
Enjoy, guys. Thank you. See you guys tomorrow. Bye, sir.